and versioning. So we have an identifier for our term. It stays fixed to the kind of meaning of that term. And if it changes over time, we have a few options. We can revise the term slightly, or if it changes in a big way, we can, obsolete that identifier and create a new identifier. And then we have a chain of provenance to say, here's the old term. You can still resolve it, find all the information about it, but it's deprecated, and we suggest using this new term. And so you can trace the history of the terms over time through those annotations. And the key point is that the data that you've annotated today will continue to be useful into the future. And so we're dedicated to that principle. And then the second question is about kind of discrete versus continuous. So in the real world, one process flows into another, one thing kind of flows into another. And ontologies do seem to be quite kind of binary or discrete with sharp boundaries. I think that's a fair assessment. And I don't have too much to say about it. Just that I think we do. I've been very forgetting where's feedback.
Yeah, we're trying to figure out.
I know what we do.
First.
This one's off. Oh, turn off that one. Okay.
That didn't work.
So it's still picking up.
Is there any in the conference who's not on?
I am. So I'm going to present through my computer.
No. Technically,
I hear the audio and stuff.
yeah.
We have like 2 minutes left.
So that would be my response. I would like to do the continuous stuff kind of next. But if that's not fair, we can talk about it later. You should go.
Oh, there's another question.
Yeah.
Issue. So I like to call that version radius. I adopted that from someone else. So you mentioned GUIDs. Who makes the decision of what's happening with those? So if something is retired or if there's a big axing change to a concept, who's making the decisions? You use the term.
Yep. So it's distributed system. So we have a community of open source projects, and they're all working in the public on GitHub issue trackers, and there's processes. But basically, someone proposes that a term be deprecated, replaced by something else. It'll be on an issue tracker. It will be publicly posted and discussed in public meetings, and then eventually it'll happen. But
we're talking about millions of concepts. Where's the manpower, person power for that?
So, I mean, we have hundreds of thousands of terms, but so if we're going to talk about funding and manpower, then that's a different discussion. They tend to be additive more than deprecated. We add a lot more new terms than we deprecate.
So related. So I'm from a protein structure mode, and we're of they call it classification system. One is kind of manually created, the other one is automatically.
Yeah.
Based on objective, mathematical objectives. So is that maybe an example in the future to update things automatically?
There are projects that are building ontologies for like large sets of cells in a more automated way. That's great. And I mean, so if you're thinking of like unipro approach, we do connect up with them, and there's that combination of manual and automatic curation in different settings. So those we do, different projects projects handle those in different ways. And the OBO community is a distributed community of different open source projects, and some of them are quite small and not well funded, and some of them are large and well funded, and they do approach things in different ways. But we try and get these principles and best practices and tools so that you can interoperate and use this one and that one together at the same time, which is an accomplishment. All right. Are you waiting?
Yeah.
I would like to go on to Nicole because I took extra time. Thank you.
Okay, should be working now.
Can everybody hear me okay?
Yes.
Okay, cool. All right, hi everyone. I'm Nicole Vasilevsky. I'm from the University of Colorado. I'm part of Melissa Handel's group and the Monarch Initiative. And I'm going to be talking, going through some hands-on basics today. So we sent out this survey in advance to kind of see what people are interested in hearing about. I recognize some people in the room and know that some of you are already familiar with how to use Protege. I'm going to do a really basic introduction. So those of you who are already familiar, this can be a very big refresher. We have about 45 minutes. We have until 10:15 when we'll have a coffee break. So I really want this to be tailored to what you all are interested in learning. So I have some material here to go through, but if you have specific questions or specific things that you want to learn, I can try to show you some of the basics that how we edit ontologies using the Protege ontology editor. So first I want to point you to, so we have our agenda, which I posted in the chat. So if you scroll through the top of our, down through our agenda, at the very bottom, I have an outline of what I want to show you today. I'm using my own computer because I want to be able to, oh, the chat is, Anthony, are you still in here? Did you leave? I don't know why the chat is overlaid on the,
Yeah.
it must be this one.
All right, sorry.
Okay, there we go. Okay, so yeah, so I'm first going to show you through the Protege ontology editor. Based on the survey results, it sounded like some people were interested in learning some of the basic functionality and then also learning about the plugins. So I'll just give you kind of a basic overview of Protege and the plugins. I won't go through the actual installation of the plugins since I already have them installed, but I can show you instructions that we have where you can go through these yourself. So how many of you actually have Protege installed on your computer? Okay, almost everyone. Okay, so maybe we don't need to go into too much detail. Would you guys like to see an overview of Protege? Kind of just like basic features of it, or are most of you familiar already? Does anybody want to see? Okay, yeah. Okay, so some of you do. So okay, we'll do that. And then I'm going to take you through an example of how to go through adding terms to Protege. So basic ontology maintenance workflows and practice with reasoners and making pull requests. So I think what I'll do is first I'll start with just kind of giving you a basic overview of Protege and show you the training materials that we have documented. And then I'm going to do a demo of an actual working on a ticket and the workflow that we do. And then I'll just go through some of the materials that we have. So if you are on this page, you're already in the OBOK or the OBO Academy documentation. So these are training materials that we developed over the last year or so, where we're trying to document everything that we do with building ontologies as part of the OBO community. So this OBO training material is meant to be for you, and also we want it to be contributed to by you as well. These materials are meant to capture all of the different workflows that we do as part of our ontology development processes. So this includes things like what I'm going to show you now, the basics of adding terms via Protege or making edits to ontology terms. It also has a lot of material that's more advanced, like how to use robot, which Becky's going to talk to us about after the coffee break today. It has information about ODK workflows, Sparkle queries. There's all kinds of information in here. It's in this make.docs file. It's all built using GitHub. It's super searchable. You can search on any terms that you're looking for. So if you wanted to learn how to use the ELK reasoner, just search on this term and I'll show you which pages have information about this content. It's all divided up into lessons, tutorials, how-to guides, reference guides, explanations. So there's a lot of good content in here. All the lessons are intended to be self-paced and done on your own. So the hope is that if you are trying to learn how to use Protege and do these kind of basic workflows, that the material will be in here where you can go through it. It's kind of step by step on how to do these kinds of editing and such. So that's just kind of for your reference. I'm going to go through some of this material today. So first we'll start with the Protege Ontology editor. This links out to a page on some basics of using Ontology. So using Protege and Ontology. So this takes you through how to clone a repository from a GitHub, or how to clone the repository from GitHub. So if you go to the repository, they go to a Ontology repository page. This takes you step by step how to clone the repository. It looks like we have a combination of people using Macs and PCs. So a lot of the materials that we've developed are based on the work that we've actually done. And a lot of us use Macs. So it's a little bit biased towards Mac users. We do try to include documentation on how to do things using a PC as well, but it might be a little less complete with a PC. This is a great opportunity for those of you PC users to add documentation on how to do these workflows using a PC if you are using those workflows. So this page here is on contributing to ontologies, shows us basics on how to download ontology files. This is using GitHub Desktop, which is I think it's a software that's just for Mac. Or does anybody know? Does anyone use GitHub Desktop on a PC? Okay, so I guess you can use it on a PC too. So yeah, this is a nice interface for working with GitHub repositories. So this is just material on how to download a repository from GitHub and then open a file in Protege. So most repositories that have been set up by using the Ontology development kit are have the same file structure for all the ontologies, which makes it really helpful to be able to know where to find the files. So most of the ontology repositories are set up this way, where we have like your main ontology folder, and then we have the release files kind of in the top level folder, and then the edit file. All the ODK ontologies are set up as with the edit file, where this is a file where you edit, make changes to the ontology, and then the release files are released on a regular ad hoc basis, and then those are available in the top level folder. So all the edit files are in the source ontology folder, and this is the file that we will edit. One of the ontologies that I work on primarily is the Mondo disease ontology. So all the examples that I'm going to show you today are going to be in Mondo. A lot of the documentation is documentation that I wrote for Mondo and then added it to OBO Academy. So a lot of the examples in the OBO Academy documentation are also using Mondo. That's the reason why. They don't have to be about Mondo. So anyone's welcome to go in and add other examples of other ontologies, or it could be about anything. So yeah, a lot of the material here is kind of biased towards Mondo, since because I wrote it for Mondo and then just reused it in here. If anyone wants to update that, anyone can update these materials. They're at the top of every page. There's a little edit link that'll take you to the GitHub repository. You need to have a GitHub account in order to edit anything using GitHub. To edit any ontology, you would need to have a GitHub account to make changes, but you're welcome to make changes to this material and then create pull requests. And I'll go through the workflow of how to make pull requests too. So yeah, so thinking about the ontology basics, we have, and then I really like the way this repository is, this documentation is created, because we have on the right hand side, it uses all the headers to create like a table of contents too for all the content. So so yeah, thinking about the basics of Protege. We have documentation here about how to open Protege. With larger files, we run into problems where sometimes for Mondo's an example, Overton would be another example. If the file is too big, you might have problems opening the file, so you need to increase the memory in Protege. So we have documentation in here, I think, as a how-to guide on how to increase the memory under how-to guides in Protege and your Protege setup. So everybody, not everyone, but a lot of people here already have Protege installed and set up. If you're new to using Protege, this is a really helpful guide here, the how-to guide on Protege, then setting up Protege, installing ELK. This is where you'd want to look for this documentation. And then in this documentation too, I believe there's instructions on how to increase your memory. And so files like if you're using Mondo or Overton, something really big, you'll need to increase the memory in order to be able to open the file. So please feel free to interrupt me with any questions too as they come up. Oh,
I don't think I have the plist file in the path that's listed here for where to set the memory settings. Is that possible? I didn't look real hard. I just did tab completion and tried to type out the path that you recommended.
yeah.
Application Protege. I have an application Protege .app, but I don't have an application Protege 5.5 etc.
James is going to come help you troubleshoot. Yes, you have a question? That's a good question, and might not be the best person to answer, but I'll try to answer it, then anyone can jump in and let me know if otherwise. My understanding is that Elk is a lot faster. Like Hermit is super slow and takes a long time to reason.
I can
Yeah.
also add some context to that. It depends on
Oh.
the OWL profile you're using. So Hermit is really good for complex ontologies in the DL profile, but if your ontology is not super complex, you can just use ELK and it'll be a lot faster. Yeah.
ELK's really good for EL++. So SNOMED is distributed in RF2. SNOMED can now be converted to OWL. When you load SNOMED into Protege, ELK is preferred because SNOMED and OWL is the EL++ profile.
No.
SNOMED is not a no-go.
Yeah.
It's not, this is that's gonna lead to another. That's just gonna, I don't want to go there.
Yeah. I think that was important to show, but I'll mention that I called it that's a really great place to look at. I just recently. This is it's not part of OBO. So I think all of our ontologies are in OBO.
I think it's a way to.
Yeah, this is yeah, it's kind of in there, but I don't. As far as I understand, I've actually really worked with Sarah's. I think they have to do like a change for process on the website, so it's not a good difference in ontology. Yeah, so you can have the changes and not restrict. You can't edit it exactly like we can edit our ontologies. Anyone have any questions right now?
Yeah, so, I mean, the main thing is that for many ontologies, we can, cell ontologies, try to reason it in Hermit. Basically, you can't ever finish with just like closing you up and you have to fill the Hermit. So that's, ELK though, it's like done in like 15 seconds. So it's just, yeah, it's like practically more useful. Right? I guess for me, I'm always back on I mean, it's funny because different reasoners work better on particular ontologies. But it's always been the case that ELK is easy to use because it corrects or reasons over 95% of what you want in typical ontology. Takeaways based on the profile. It's a question for the war room. Does it have any paradox with other editor in position? In the similar web, there may be something.
Other software.
Yeah.
A very popular piece of software. Very popular piece of software for non-OBO, editing is Top Grade Composer, but it's expensive.
Back in the day, before I started, everyone was using OBO edit. Were you using that? Yeah. When I started, I came on about 12 years ago, and everyone had recently switched to Protege. And then I heard so many people say like, "Oh, we just OBO edit," and I never used it. So I used it a few times randomly, but I wasn't like it wasn't my tool. And I guess I had a lot of advantages over Protege. People complain about it, but no one uses it. As far as I know, no one uses it anymore. We all primarily use Protege. There's also a web Protege that can be easier to use or easier to install, I think, if some people end up using it. My current little lighter version, it's a kind of lighter version, doesn't work well.
Yeah, what? Web Protege is really nice, it's collaborative.
Yeah.
So you have many users working on the same ontology. What web ontology lacks from desktop Protege, however, is some really interesting features like a classifier. You can't have a classifier in web Protege. You can download your ontology and you can import it into your desktop Protege or your classifier. But there are also other features such as the usage tabs for your practice, and you can't see which classes are being used for it. So, but collaboratively, it's really nice because you can comment on classes and have it sort of like the track changes, I guess, for Word. But yeah, it's getting there, and I will just help Stanford beat the drum here, but they're always looking for letters of support to continue development.
That's the same for Web Protege. That's the Protege itself has a GitHub tracker too, so I definitely encourage you to send them feature requests. But my understanding is that they don't have funding at the moment to develop Protege, but so they can't make a lot of major changes, but back here. Woo! Can you all hear me? I'm back in front of my computer.
Better.
Yeah, so Protege, there's a GitHub tracker for Protege, and the team is super awesome. So I would recommend if you find features that you would like to have in Protege or Web Protege, definitely go ahead and ask them. And also, if you run into problems using Protege, it's really helpful to search the tracker too. Let me see if I have it bookmarked. Just if you have trouble with functionality, it's always helpful just to go, I don't have it bookmarked, but just look through the tracker and see if that someone else has already asked that question. It's a good place to try to find the answers. So they have a repository for Protege and then one for Web Protege. So they have had over 1,000 tickets on their tracker, so or close to 1,000. So there might be, maybe you have the same question that someone's already answered and been closed. So this is a good place to find solutions too. So yeah, come to our OBO Academy documentation or look at the Protege issue tracker. So yeah, so along the question with using the elk reasoner, we have instructions here on how to install the elk reasoner. So in my experience, I've recently had my computers reimaged or got new computers, so I've had to install everything again. So in this process, I've documented the workflows to do this. It's always a big, it's a kind of a big lift to get everything set up and installed properly. There's two different approaches here. Sometimes I've had one of them work for me and not the other one. So hence we documented two different approaches. So this is the workflow that I recommend for trying one of these two approaches for installing Protege or installing elk into your Protege, the elk plugin. These instructions are for a Mac, and then actually I recorded a video explanation of how to do this. I don't have instructions for how to do this on a PC, so PC users, if you know how to do this, we'd love it if you could contribute this documentation so other people can follow these instructions. So I was going to next switch to talking about how to contribute to ontologies via GitHub. Does anyone have any other questions or anything they want to discuss before we go down this path? Okay, so I'm going to just, so talking about ontology maintenance and workflows, I'm going to, there's a lot of documentation we have here. These links go to our lessons on, we have this contributing to OBO ontologies documentation, which we kind of looked at already. This has a lot of detail, kind of step-by-step on how to contribute to ontologies. I also have links here to practice with reasoners. This is a, so we have, like I said, the materials divided into these different kinds of categories. This is an explanation on using logic and ontologies and using axioms. So this is something that I would like to just refer you to for looking at in the future if you're interested in this area. And then I did this lesson recently on as a tutorial on doing pull requests. So I'm just gonna take you through all this material, not by just going through all this documentation here, but by just doing this in real time right now with a real ticket even. So yeah, like I said, I'm the lead curator for the Mondo disease ontology, which is a unique ontology in some ways in that it aggregates a lot of underlying source ontologies into this unified ontology. So Mondo has disease terms that come from external resources that we've aggregated together and assigned Mondo IDs to all of them. We're an actively developing ontology. Our group is funded to work on this, and we have a pretty big team of people who have proper dedicated FTEs to work on Mondo. It's under continuous development, like all ontologies, and we get a lot of term requests from the community, and we write term requests to ourselves, or requests for changes and such. So Mondo has a lot of terms that are coming from external sources, but sometimes we like to create new terms in Mondo. A lot of times grouping classes, we want to classify terms in different ways. So this is an actual real ticket that on a call, we decided we wanted a new term to group together the neurodevelopmental disorders that have a underlying genetic cause. So I'm going to take you through the process of being an ontology curator and how I go about addressing tickets for the Mondo ontology or other ontologies too. I work on a lot of the OBO ontologies. So as a curator, I would come to GitHub and see these open tickets. As ontology contributors as yourselves, these OBO ontologies are open, and you're welcome to contribute to all of them. So you're welcome to come to any repository, look at the issue tracker, comment on them. If you want to take a stab at addressing some of the tickets, you're more than welcome to do this. So in Mondo or any of the other OBO ontologies, these are all open and community-based. So so this is a ticket to add this new term. So I'm going to do this via pull request and make the edits in Protege. So I would come to this ticket, look at the request that's needed. I created this ticket, and this is an example of a pretty bad ticket where I didn't add very much information. Everything's written in abbreviations. Luckily, I remembered, this is, it's been a few months now since I created this, but I still remembered what this means. This is an example of a bad ticket. If you're writing a ticket for a community tracker, this is not following best practices. You'd want to try to include a lot more detail. Definitely don't leave abbreviations that are undefined. Using the checkboxes is really nice. If you haven't seen this feature before, I'll just show you. I'm in edit mode. You can write out the syntax like the dash space and open brackets, and this will turn into a checkbox. Also, in GitHub, in the issue tracker, they have this little, what you see is what you get interface where you can just use these little boxes, check this box here and it'll create it for you. The checkboxes are really helpful because then someone will know the exact action items that are to be done. But yeah, so this is a better example of this comment that I left below. I wrote this as a note to self, so I know what to do to demonstrate this to you. But this follows more details. So now I know what the term label is supposed to be, what the parent term is. We add source annotations to our parents in Mondo, which is something that's unique to Mondo, but I think it's really cool because we actually can track like why this secret class was asserted. And then, so this is linking to the ORCID ID for Peter Robinson and Ada Hamash, who are the ones who suggested this term. So we can go back and say, if we say, we're like, why is this classified this way? We can see it was due to their suggestion. We also in Mondo link to all of our external tickets, which I'll show you. And that's a really nice way too. Is like if you go back and say, why was this term created? Then you can go back to this ticket and see the documentation, like, oh, this came up on part of a conversation and we decided that we would add this. And then I'll add a lot of logical definition too. And then you can see, I'll show you the reasoner. So I'm going to go through this step by step. So come to the ticket. I always create a new branch. So working on a branch. So this is going to create like a local copy of the file on my computer, and then I'm going to push it back up to GitHub and then create a pull request. And then someone external can come and review the pull request and say, okay, this makes sense. This was done properly. This biology makes sense. Yes or no, leave comments to me or not. And then we can add the term. So to add a new branch, I can go here to master. I'm currently on the Mondo file. you want to make sure when you're on GitHub Desktop that you go to the right repository. So I have a lot of different repositories downloaded here. So if you haven't, you have to first clone the repository. If you haven't done that, make sure you're on the correct repository. I'm on the Mondo repository. I'm currently on master. Out of kind of a force of habit, I always pull the ontology before I make any edits to it. And then I create a new branch. I can either click new branch or I can just start writing the name. And I like to name the branches after the ticket number. This is something I learned from the Go editors. The Go documentation is also very detailed and great. And a lot of the documentation that we have in the OBO Academy has been adopted from that too, giving credit to the Go team. So I can start writing the issue, write the name of the branch, and this branch doesn't already exist. So it'll tell me to create a new branch, or I can do that way, or I can just do new branch and then name it here. So I'll create a new branch. Now I want to go to Protege. This is a new feature that the Protege development team added a few years ago, and it's super helpful, where you can see the issue or the branch that you're on underneath at the bottom left here. And so I'm going to go to the active ontology and or I want to go to the entities and classes. So I'm going to add this new term. So first what I want to do is I'm going to add assert this as a subclass of Mendelian disease. So I'm going to just copy this label here and then search for it. I can also open the search by just doing Command F on a Mac. I think it'd be Control F on a PC. Search for this term name, find it here. One of the cool things that I just recently learned that I'm actually really excited about is if I click on this button here, I can just copy the display name or copy as markdown. So that's what I did here, because this is actually linked. If I open this, this is linked to, it links out to the Ontology lookup service, which is a really great browser for looking for terms. And this is what this looks like. This is just copied directly from Protege using that copy markdown, or what was it? Copy as markdown, yeah. So that's a new feature I just learned recently that I'm really excited about. You can also copy the OBO ID, the display name, the IRI. It's very helpful. So I found my term I want to add as this is the parent class I want to add. To add a new term, I just go to this button here, add subclass. So I'm going to add this new term, Mendelian neurodevelopmental disorder. I already have my preferences set, so it's automatically going to assign a new Mondo ID. That's the next ID in my ID range. Is everyone familiar with the ID range or no? So in the OBO ontologies, we've assigned each other ID ranges. So all the ontology IDs are 7 digits long, and we don't want to overlap with each other. So I edit the ontology. There's several other people in our group who edit the ontology. So we've assigned each other all the ID ranges. So I'll show you the file. And so the ID ranges are always set up in the same kind of structure too. They're saved as an OWL file, and I don't actually know why that is. But I'm just going to drag this and open it with Atom, which is a text editor. So we can see the ID ranges here. So ID range 1 is assigned to Chris Mungall, so he gets every ID between 0 and 99,000 or whatever, 99999. I get the next group of ranges. So I set up my preferences. So all my preferences are between these two numbers. And then we've assigned additional ID ranges to other editors. And this is like a permanent file that we use. Yeah.
This is really a good practice that makes a lot of sense for managing and contributing. I don't know.
Okay.
The ID ranges document and some of the other things you said about URIs make a lot of sense for adding to an existing OBO Foundry ontology. Are there any hints for if I want to start something just from scratch, very experimental, no OBO namespace has been assigned to me? Are there similar practice, like, you know, what should I make the base of my URLs look like if I don't want to use, like, you know, my name / semantic web or whatever it is?
Yeah, here. So,
Yeah. So yeah, if you're just starting a I think it was just I mean, maybe someone else has an answer for this too, but if it's just an ontology that you're playing around with, I think you could really name it however you like. Yeah, it won't get I mean, maybe you would want to, it wouldn't get the OBO kind of Perl until you actually got it accepted into OBO Academy or into the OBO Foundry. But yeah, I would suggest almost even just trying to be conformant. If you're planning to submit it to the OBO Foundry, I would just try to be conformant with the OBO practices right away.
Are you working in Protege? It has a few different default settings. Protege has a few different settings for just like incrementing identifiers.
Yeah.
In the same place. Anyway,
So I could make myself a base URL in the OBO Foundry pattern and then hope that namespace would be offered to me later.
I don't know. The traditional one is to use example.com,
Yeah.
but Protege has a few settings for just default identifiers and they can navigate easily.
Yeah, we actually did develop, my colleague Sabrina is going to talk tomorrow about an ontology that we she recently created called the vertebrate green ontology. And Chris will help us with that. And yeah, I think we just tried to follow all the other best practices. We knew we were going to finish the OBO Foundry. And then after when turning the prefix, we wanted to make sure we weren't using a prefix that already existed in OBO. Because then it means we have to go back and change it later. And we did set it up initially as a unit, I think it was like a unified green ontology, and then I think that maybe VBO already existed, so we were like, we can't use it, and then changes to VBO, and there was actually an ontology that used VBO as abbreviation, which I think it was in the medical foundry, so we were probably okay. But I would just start off using best practices, even if you end up just trashing the whole thing. But then if you do keep it and sort of type of foundry, then you're just set it for success.
I've been working with the Alloy Band for maybe 15 years now, and I have a question. In OBO, you call it a URI, but now in OWL, we call it IRI. What's the difference?
Yeah, I'll say that one. There's technical answers. So like URLs are ASCII encoded, like with an HTTP prefix, whatever. And there's another standard called the URN, and then those got merged, and then IRIs are also allow for Unicode encoding. So IRI is the biggest umbrella for all these different schemes. In practice, pretty much all the time. In practice, all the OBO identifiers are URLs. So they're just like HTTP ASCII characters, and so. In practice, all the OBO things follow the oldest standards of the web. And then, but yeah, in OWL API, they're sort of the most IRIs because that's the fully general spec. So there's a family of different specs. IRI is the most general one. And then, but in practice, we're using this small old subset of URLs. And then URI is in the middle, and IRI is the full umbrella. I don't know. It's kind of boring.
Is there hopes for a future stack that would allow an IRI in OBO?
Oh, well, I don't know if we need them. So we have our HTTP perl.obolibrary.org, like /OBO, and then / our ASCII identifiers and a number. And so we don't need Unicode for that stuff. Which is part of our
non-Latin.
Oh, so we can handle language labels and things. That's no problem. Fully internationalized for all the annotation content. But since we're using numeric identifiers in our own space, there's no need for anything other than old-fashioned URLs. Yep.
But people would call them IRIs.
Yeah, I don't know. People are inconsistent. And I am also inconsistent. Yep.
Does Protege actually support Unicode characters? Because I've had trouble opening files where I've created IRIs with like semantic characters. Does Protege support Unicode?
It should. It should be. Yeah, it should be fully supported. I don't have emojis.
Okay.
problem with Unicode characters, so too, sometimes they get an error,
Yeah,
because Unicode character.
should be fully supported, so it's all like, by default, we're saving it in RDF-XML format, which is like UTF-8 standard. And so, and the OWL API is IRI, which should be fully Unicode, all based on Java strings. So I wouldn't expect a problem there. We run into problems when I like run stuff through Excel or other systems. But in principle, the whole semantic web stack is fully like Unicode compliant and internationalized, all these things. So in principle, all this tools should work. And if you have specific problems, they sound like bugs, then we should fix.
The header of your ontology should specify what you're using, whether it be UTF-8, UTF-16. I believe so.
Or, I think,
Along similar lines, what are the best practices for including special characters, which examples would be something with a diacritical mark or a quotation mark in annotation properties? And especially, what about doing some editing in Protege, and then maybe sometimes also sneaking in an edit in a text editor? It seems like there's a lot of potential for either putting in some quotation marks that would break things, or ending up with something that looks funny in either the text editor or Protege.
So if you want to be fully safe, just don't do that. But no, you can shoot yourself in the foot in lots of ways, especially like platform specific encodings, editing something, opening it up in like Notepad on Windows. It's gonna come up with a different default encoding unless you're careful about it. So I don't know. There's no good general answer for that. I'm sorry.
I re-import external terms, a lot of international sources, using names, accents, whatever. And yeah, Protege was taken by when they'll display it really weird. So a lot of times in like if you're looking at Mongo, like an LLS, will see like the letters, instead of having like an A with an acronym, it will turn into like two random letters. We have to take them to Mongo constantly.
I don't know if this will be addressed like later on, but how do you deal with when you're importing external policy and there are like logical inconsistencies? I guess, how do you deal with that?
That happens, that's a great question, that happens a lot. So I think a lot of times it's have to go back to the work ontology and say, I think maybe this logic is interaction with different set of source. So that's definitely best practice. We could just try to fix it in your ontology and make it work, but that's definitely not what we hope you would do. We hope you just like if you bring in like an Uber on term that can be some kind of problems. Like we had a problem where in Mondo where we had like some kind of muscular disease is getting inferred to be a child of neuromuscular disease that was truly so in the way that Uberon had classified vessels or something was having this weird difference in Mondo. We could have just kind of passed it together in Mondo fix it, but then like Uberon because this is truly how things like vessels should be classified. So we would want you to go back and refer to the first ontology if it's coming logical errors in their ontology.
Yeah, I think we'll talk about a few different import strategies in the second half, robot and ODK. So you'll have some options there. But yeah, if the problem is that the upstream ontology is broken, then that's a bug and they should fix it. But more likely the problem is when you import a bunch of these terms here and a bunch of terms here and a bunch of terms here, they don't play nicely together. That's probably the case that you're thinking of. And that is kind of a bigger problem that we're working really hard to fix that at the OBO level. So we have our OBO dashboard, which is checking all the ontologies as they're like being updated, making sure that they're working well. And then we have the notion of a base file, which maybe we'll talk about a bit later, but it's like stripping out most of the imports and it's allowing you to focus on the ontology's core content and then allows these things to be merged more cleanly. And then, yeah, and then we're working on quality control for like pairwise or groupwise merges of different ontologies to make sure that they're consistent in groups, and communities. That's another goal. But so, yeah. There's different ways you can shoot yourself in the foot, but if the upstream ontology is broken, that's a bug to report. And if it's some weird combination of things, it could also be a bug to report. And then we'll present on a few different import strategies you can have for managing those kinds of things in the short term. And if we don't cover that, then ask me about it and I'm happy to talk about it.
I just want to make a comment on the characters. Sometimes you'll have, so in practice, when replacing a character and getting into another environment, so let's say you add a division, you have someone on your editing team who adds or copies and pastes something with a division symbol within an annotation or an indentation, and then you're trying to import that into something that won't like that because that character is absent. One tool that we found really helpful at NIH is NLM's lexical variant generation, and that offers a utility that will let you configure a character replacement map. That's really useful in workflow. So that's just
You say the name of the product here.
lexical variant generation, LVG.
All right, thanks for all the questions. I'm going to keep going with adding this new term and oh, and then also I wanted to point out this page here, the question about difference between IRIs. We have some documentation like, from some old slides defining URNs, URLs, URIs, and it looks like it didn't all make it into here. I can try to update this, but there is in the OBO Academy documentation, there is some documentation in here that addresses part of the question. So, oh, Candy.
Oh, thanks.
Yeah, keeping my eye on the time. Yeah, so I'll just keep going through this workflow here. And then, yes, we'll be stopping in about 7 minutes for, oh, that clock is wrong. Oh, we have 2 minutes. Okay, got it. Okay, well, I'm really fast at editing, so I'm just going to quickly add these terms. So, so we like to add the source annotations to the terms, to the subclass assertions. Note also in Protege, Protege is very particular. You don't want to have any extra spaces. This will actually, and Mondo at least will cause the build to fail. Sometimes it auto fixes it on its own, but you want to be very careful with making sure you don't have any extra spaces. I'm just going back and forth, just using Control Tab to add, go back and forth between the window and the Protege screen. So you may note too that I'm adding a lot of different, doing a lot of clicks to add all these annotations to Protege. This is kind of the nature of Protege, how it's built. It's kind of a lot of click-throughs to add all the different annotations. Next up, we're going to have Becky talking about the robot workflow, and robot can easily add terms in a spreadsheet-based format, so that takes a lot of the pain away of having to do all the multiple clicks through Protege. So that's a nice liaison into Becky's. I just ran the reasoner. You can see that went really fast using the ELK reasoner. Now we get this inference because I added this logical axiom that any instance of the Mendelian neurodevelopment disorder is a neurodevelopment disorder that bear of is actually a synonym for has characteristic, just any inherited form of neurodevelopmental disorder. So this has been inferred to be a subclass of neurodevelopmental disorder. Another cool feature in Protege is that you can go, if you're clicked on the left-hand panel that has the class hierarchy, you can just click I, and it should go to the inferred view, but it's not working. Oh, there we go, slow. So if I just click I, it takes me to the inferred view, and I can look at this term. Also, gets you get this automatic inference of all these different children based on these, based on the logical definition, and we can look at the explanation to find out why this is.
I think we're getting started now again. So hello, I'm Becky Jackson. I'm going to be doing a robot tutorial. So we sent out a survey in advance, and the majority of the people that responded said that they'd never used robot before. So I'm very excited to introduce you guys to robot. I do see some familiar faces here though. So some of this may be material you've seen before, from past tutorials. So was everybody able to get robot installed prior to this tutorial? Yes, any issues? I see some comments. Okay, I'm just gonna keep an eye on the chat as well. Okay, great. So now if you guys could all go to the link that is on this slide here, I'm gonna copy it and paste it in the Zoom chat as well. This has some example material that we're gonna be using for the tutorial today. Oh, and let me turn on my video too so people can actually see. Okay, great. Yeah, so please go to that GitHub link. You can either clone or download the repository there. Yes, so if you have not downloaded robot yet, you will need to do a little bit of setup. Oh, thank you, Nico. So Nico's going to keep an eye on the chat here. The Zoom controls are always in my way.
Somebody was showing me. Oh, never mind.
All right. Yeah, so if you can download this robot tutorial, you can either clone it using this link here or just download the zip. What you're going to need to do then is go into your command line and navigate to the robot tutorial directory. And then you're going to want to navigate into the examples directory. And if you guys are having any issues with the command line, just you can raise your hand and I can come over and help you out. I did see that most of you have at least a little bit of experience working with the command line. But yeah, if you run into any issues, just raise your hand and I'll come over and see if I can help you guys out. So in the examples directory, there are some OWL files, some, oh yeah, that's a good idea. Might be a little bit easier to see what's going on in the terminal now. So there are some OWL files, there are some tables, some Sparkle queries, all things we're going to use within the tutorial today. And while you guys are getting that downloaded and navigating to robot tutorial examples, I'm just going to go over some stuff for people who have not had a chance to work with robot yet. So what is robot? Robot, it's a command line tool and Java library for automating ontology development tasks. And robot does stand for robot is an OBO tool, but it's not just for working with OBO ontologies. It's for working with any OWL ontology. It uses OWL APIs, so you can load any syntax that's supported in there. RDF, there's Turtle, OWL functional syntax, Manchester, and so on. So any OWL ontology. So robot, actually, we're now up to 27 different commands. We're not going to look at all 27 today because that would be a full day, maybe more of material. So we're only going to look at some of the most commonly used commands in this tutorial. If you're ever interested, we do have full documentation at robot.obolibrary.org. And so you can see all of the commands there, how to use them, examples, and so on. We're also now up to 20 robot releases. So version 1 was released February 8th, 2018, and now we are on 1.9, which was released on June 16th, 2022. We also have a paper if you'd like to cite robot. There's some material there. If you just search robot ontology workflows, it'll probably come up. It's also linked on our documentation site. Okay, so basic usage. If you ever want to see from the command line some help about a certain command, you can just type robot help and then the command name. If you just enter robot help, it will list the general usage. So you can see robot, command, options, args. And then these are all options that are available for every single command in robot. If you want to see more details about a specific command, you can type robot help and then the command name, for example, template. And I don't know why that did not give command specific. It's supposed to give command specific help. Anyway, the general usage for robot is you have the robot, you put your command name in, you have an input OWL file, and then you give an output file, which is commonly also an output file if you're performing operations on a file. There are a couple of commands that have some slight differences, and we'll go over those when we get to them. Okay, so just some basic ontology development tasks playing around with robot. So how can you use robot to see what is stated in your ontology? So one command we have is called export. What export does is it takes the data in your ontology and exports it out into a table. So the basic options for this is you need an input ontology. You need to specify your header, which is what data do you want to include, the fields you want to include in your export. And then instead of saying output in this case, the output is export. So that's your output export file. A little bit more about the headers. So this option, and you'll see it in practice in just a minute, you specify your field names and they're separated with a pipe because some of them have spaces in them. And then we provide some special values that you can use. So you can say IRI if you want to get the IRIs of entities, IDs, which is the short form of the IRI. You can use the label keyword to get the RDFS label. You can use the synonyms keyword, which aggregates all of the special OBO and OWL synonyms into one field. And then some logical things. You can say subclass of to get the parent. You could list out the subclasses of a class, and then type, which is the entity type. Generally, you're going to see classes, properties, but if you have instances, you'll see their type in here as well. You can also use properties, commonly annotation properties, within your ontology. So you can reference these by ID or label. So you can see here, one example is definition, which is the IAO 115 property. So you can reference that either way. So just as a first example, we're going to get a table of the parents of classes in an ontology. So you can see here we have our header listed. We use the special ID keyword to get the short form, the label to get the RDFS label, and then we want to get the subclass of statement for this. So I'm going to just copy this into the terminal. And on your end, if you're in the examples directory, you can also run this as well. So we're going to do robot export. The input file is our edit.owl file. We have our header, and then export results export.csv. If you haven't already, you will need to make a results directory, or else this will fail and tell you the file can't be found. So if you haven't done that yet, just make a results directory. So I ran my command. Now I can open this and see what the content is. So I can see here for all of the classes in my input ontology, I've gotten the ID, the label, and the subclass of. Oh, that is very small. There we go. And then by default, it's going to split multiple values with a pipe. And you can see there are some anonymous superclasses as well, and these are printed out with labels as well. So you can see organ, it's a subclass of multicellular anatomical structure, and it's part of some anatomical system. Okay. Oh, yeah. Yep. So I'll just give everybody a minute to type that out. Yes, I can. Yeah. Okay. So, like I mentioned, the ID column is always good. Oh,
Is it possible to filter on a specific language for the
A specific,
language?
not with export. That would be something you could do with a Sparkle query. Yeah, little bit harder to write, but this is just like a very simple version. Another thing you could do, you can chain commands together. So if you wanted to filter for a subset first, we do have a robot filter command, and then you could chain that into export. And I'll talk a little bit more about chaining commands in a little bit. Is everybody ready to move on, or do you still need a minute to type this command out? You good? Okay. I'm gonna move on then. So another example here, here's an example of using a property by label here. So this assumes that your input ontology has definition in it as an annotation property. If my ontology didn't have definition in it, IAO 115, or for some reason I used a different label for it, it wouldn't work. So this uses the label defined in your ontology. And you can reference any annotation property this way. So now I'm going to go back to my terminal, and I'll keep that up there as well. So robot input, or robot, I need to put the command name, export, input edit.owl. Here's my header, ID, label, definition, and then export results, export definitions.csv. Now, if I open this one, and I'll make it bigger again, you can see we have kind of the same material as before for all of the classes within the ontology. We have the ID and the label, but now we have a definition over here. And even if a definition isn't included, the term is still included. It's just going to have an empty cell for definition. So I'll go back to the command so you guys can see that again. Now, as I said before, we could accomplish the same thing here by saying AO 115. Just note that if you do this, instead of saying definition in the first row in the header, it'll say IAO 115 in right up here. So just preference, whatever you want to use. Does anybody need another minute to type this command in? All right, we're gonna go move on. So I'm going to introduce two new options for export here. So I want to get a table of parents with IDs. This time I only want the named parents. I don't want to include any of those anonymous superclasses when I'm just trying to get the direct parent IDs. So I can filter out those anonymous parents by saying entity select named here. So for all the values, it will only return named entities. And then I'm also specifying, instead of returning the label, which is the default behavior, I want to return IDs for everything. So we will put that down so you guys can still see that. Header subclass of. So now the entity format is ID, and then entity select named. Again, we have every class in our ontology over here, and now instead of before we had, let me see if I still have that file open. I do. Before we had the labels for the parents, now we have the IDs for them instead. And you can see it doesn't include those anonymous superclasses now, but multiple values are still split with a pipe. And if there are missing values, it's still empty. I do want to point out that even though our entity format is ID, if you include any annotation properties, the literal values will always be printed. So say I want to get the labels as well. So this time, my entity format is ID. So anytime an entity is referenced in one of these cells, it's going to be by ID. But since these are literal values, these are annotations, it provides the annotation value. I'll go back to that command. If you guys just need another minute to type that out. Does anybody need more time on this one? Right. Move on to one more option for export. So by default, export is just going to include classes and individuals in your ontology. So properties are not included by default, but say I want to get a table of the properties instead. I can use this include argument here with the properties keyword. And this time I want to get the ID, label, and type of all the properties. So the type will tell me, hey, is this an annotation property? Is it an object property? That sort of thing. Input, header. And it does not necessarily have to be encased in double quotes unless there's a space in it. So if you want to include multiple things, so say you wanted to get classes and properties, I would have to put it in quotes because it is separated by a space. But if there's no space, I can just say properties. Okay, so this time it listed out all of my properties. A lot of them don't have labels, but you can see over here the type is listed. And again, because I didn't specify that I wanted the ID, the type is an entity, so an OWL object property. It just put the label, but if I were to say ID, it would say OWL : object property, for example. And you can see the annotation properties. I got a couple object properties. So yeah, this is just a really simple way to see some general information in your ontology. Yeah.
Can you restrict the properties that are reported based on properties that have been, properties that are allowed in certain classes? And my example is.
Oh, thank you, Nicole.
Yesterday afternoon, I was trying to write a Sparkle query to determine all of the data type properties that are used for subclasses of chemical entities in Kelly. Could I do something like that?
Not with export. This is just a simple command. So your options for that, yeah, would be writing a Sparkle query, or filtering potentially, and then chaining that to export, like I said before. Feature request to be able to do more filters for export. Any other questions? Let me see. Yeah, I don't have these commands to copy and paste right now. They're just in the slides. I can share them. I can share these slides after the presentation so that you can go back and copy and paste these commands. Okay, go back to my PowerPoint. So yeah, that pretty much sums up export. And again, you can always read the docs if you want to see more about it. But I want to go on to query as well, running Sparkle query. So as we discussed, if you want to get a little bit more complicated in what kind of things you want to get out of your ontology, the way to do this is with a Sparkle query. This is not a Sparkle tutorial, so I'm not going to go into Sparkle syntax. There are a lot of great Sparkle tutorials on the web, so if you want to take one of those on your own time, then you can use Robot as a way to run those Sparkle queries on your ontology. So the general format for this command is you provide your input ontology, and then you have this query argument here, which is there are two parts to this argument. There's the input query and then the output. So we'll see that in action here. So the first thing you can do is just run a select query. So for the query, you can see I have my input, and then this query argument here, the first parameter is select.rq, that's my input Sparkle query, and then the second one is my output file. And you could also do a CSV if you wanted there. And this is going to be the query we're running. So we're just selecting the ID and label. So this is essentially the same thing that export did. If you said export ID and label, this is just showing you can do it in Sparkle too. Usually you would be doing a bit more of a complex query. Otherwise, you could just use export, and then you wouldn't even have to write a query to do that because the query has to be a separate file. So I'm going to move this down. Robot query, do my input edit.owl, query select.rq, results select.tsv. I don't think I can make this bigger? I can make it bigger. Cool. So this is just my text editor. I'm just looking at a TSV. You can see, again, it's pretty much the same thing that we just looked at in export, the ID and the label for everything. I didn't restrict it to just classes though, so there are properties. And also the other difference is, since I didn't say that label is optional, it only returns terms that have a label. Whereas export will return everything, even if it didn't have a label, and the label cell would just be empty for that one.
How is export implemented internal? Is it a Sparkle query or just some?
It is, yeah, it's not a Sparkle query. It's just using OWL API to get the details about the entities. So you can run different kinds of queries. There's also, you could run an ask query. It's input in exactly the same way, except this time in our Sparkle file, we use the ask keyword, which will return a true false value. So in here, I want to find out if there is a term trunk that's in this particular subset, vertebrate core. Let me make sure you guys can still see that if you want to type that yourself. So this puts out the results to ask.txt. See, true. Yes, there is. Another thing you could do if you just wanted to see really quick, you could just, or cat. That's what I want. So then you can see true. All right, does anybody else need more time on this slide? All right, moving on. Okay, so we talked about what was stated in our ontology, but how can you use Robot to see what's inferred by your ontology? Well, the first command we have a reason command. So this takes an input ontology. You can specify a reasoner to use if you want. The default is elk, and then an output ontology. So the output ontology will be your original input ontology plus any inferred statements. So the first thing that reason does is it performs a logical validation. So if you have any issues with your ontology, for some reason your logic isn't correct if you have an unsatisfiable entity, meaning no instances can ever exist of this entity, or you, even worse, you have one of those classes and then you also created an instance of it, in which case your ontology is severely broken. The first thing robot does before adding the inferred axioms to the file is it just validates that there's nothing wrong with your ontology. So we have this unsatisfiable.owl file in our examples. So I'm going to say robot reason input unsatisfiable. I'm not even going to put an output because I know it's going to fail. And then you see here, I get an error message. There's one unsatisfiable class in my ontology, and it actually tells me which class that is. So then this is really helpful for debugging, because then I can go into my ontology and go look at that class and see what's wrong with that class. Another, I don't know if I didn't, one thing you can do, so this unsatisfiable.owl file is a really small thing. I think there are like 2 or 3 classes in it, but say you have this really big complex ontology and you get this error message that there's one unsatisfiable class in your ontology. One thing you can do is you can dump the unsatisfiable module with the dump unsatisfiable command, and then you provide a path to where you want your file.
Like user class actually called x.work. Like if it was like, if I was using like Mongo.
Oh yeah, it would be like perl.obo library. Yeah, this is the actual URI of the class.
Okay, so you get the full URI.
Yes, correct. So I'm dumping my unsatisfiable module. It gives me the same message, but now I can see that in my output directory, there's a results unsatisfiable.owl. Just as a side note, this when this command runs, so a little bit about when a command runs successfully, it has an exit status of 0, which is really useful for automated workflows. When the robot reason command fails, it returns a non-zero exit code. And typically in robot, that means the output file is not created, but with this unsatisfiable module, even though it's a non-zero exit code, there's still an output file. So I can see this little $sign question mark just is tell me the exit code of the last command that I run. And you can see it's a non-zero exit code, but I still get an output file. But typically for a non-zero exit code in robot, the output file is not created. So the second step, after robot makes sure that everything looks good in your ontology, it adds the inferred statements to the output file. So now I have a good file that I know is not broken, this non-reasoned.owl file. And I just want to output everything to reasoned.owl. So again, this is the input file plus all the inferred statements. And again, I'm using the default, which is the elk reasoner, but you can specify reasoner with that reasoner keyword. So quickly, I want to have a little interlude. So I could open that file in Protege and look at it and try to see what was inferred. The other thing I can do to see what inferred statements were added is I can perform a diff. Robot actually has a diff command that you can compare 2 ontologies with. So I want to see what the reasoner added to my file. So I'm going to go robot diff. My left ontology, which was like my starting ontology, is non-reasoned.owl. My right ontology, which is my new one, is this reasoned.owl, and then my output, let's just call it diff.diff. And there are a couple of different formats you can do. Sometimes for really big diffs, I like to do an HTML format. So I will just show what the standard one looks like. Oh, what did I do wrong? Oh, output. That's what I did wrong. Output. So here's what the standard plain text looks like. Okay, so 0 axioms in left ontology, but not in right ontology. So nothing was removed, which is good because the reasoner shouldn't be removing when I just do it like this. 3 axioms in right ontology, but not in left ontology. So these were the things that were added by the reasoner. The other thing, like I said, you can also do it in HTML. So I can say format HTML, open results diff.html. And it gives me this nice, nicely formatted HTML page that I can use to review. And it's also nice because there are links in here if I ever want to link out and look at a certain term. So that's just a nice way to see what's been added by the reasoner. And obviously it's not just for reasoner. You can also, if you're editing your ontology and you want to make sure your diff is good, you can run it before you commit your changes to GitHub. We already kind of talked about this in the last session. I just wanted a quick note on, hey, what reasoner should I use? Yeah, ELK is our default. It's fast. It's for the EL subset. Hermit is going to take a lot longer. It's good for really complex ontologies, but it can be very, very slow depending on what there is. There are a couple of other reasoners that are supported by Robot, which you can see all the reasoners that are supported in the docs. But in general, these are probably going to be the 2 that you'll use. There are a few other options to use with the reason command. So one thing you can do is you can annotate inferred axioms. So when I do this, let me go back to, okay, so I have my reason, input, non-reason. Let's annotate inferred axioms true. And then when I open this in Protege, go over to my entities. You can see here, here's a new axiom. It has an annotation on it, is inferred true. Okay. Another thing you can do with reason, say you want to create a new ontology that only has your inferred statements in it. So reason takes your input ontology, adds the inferred statements. You could just have an ontology with only the inferred statements in it. So create new ontology true. If I just do that, I'm not going to bring along any annotations on my terms. So none of my terms will have labels. If you want to include the annotations on the terms in that new ontology, you can create a new ontology with annotations as well. The last thing, remove redundant subclass axioms. You can do that as well because the reasoner may assert some redundant information. This just helps keep it a little bit cleaner. All right, so that's just some basic tasks. Now moving on to more ontology development focused tasks. How can you create ontology content with Robot? And Nicole briefly touched on this command. I think it's probably our most widely used command, or maybe not most widely used, but it seems to be people's favorite. It's my favorite, is the template command, which allows you to take material in table format and create ontology material from it. So the arguments you can use here is the input keyword. So this is actually optional for template. If you are referencing properties or classes from your ontology in your template, you can use the input ontology to reference them by label so that Robot knows the labels of things. Or you can actually merge the content into your input ontology, which I'll talk a little bit about more about in a second. The one that's required is the template argument. So this is your template source file and then your output ontology file. So what does a Robot template look like? The first 2 rows of the Robot template are kind of the important stuff. So the first row is human readable column names for your template. And then the second row is the Robot template strings. So these are telling Robot what to do with the contents of the cells. So these are just some examples, and I'll get into what these specifically mean, but we have the term ID, what the label is, the type, some sort of annotation you want to add to it, and then here's the parent of my class, which you probably don't need to assert that something is owl thing, but this is just an example. So a couple of special template strings here. So we've already seen these in export before. So these are familiar. The short form of the term ID, which is here, and any prefixes that are referenced. Robot comes included with the standard OBO prefixes. So if the ontology is part of the OBO foundry, you can reference the prefix. So I could use, for example, OBI here, and it would know what OBI means. But if I'm creating something new, I would have to make sure that my prefix is added to the robot prefixes in order to reference that. And then term label. So this will be asserted as RDFS label. And then term entity type. So typically, if you're just creating classes, you actually don't need to include a type column because class is the default. But if you want to create annotation property, if you want to create individuals, then you will need this type column, and you can use classes for creating individuals. Yeah. Yes. So in the documentation, why did I? I'm already on it. It is. Okay, so these are just some default types that are supported here. So you could say class, you can say object property, a data property, annotation, data type, an individual. If you are creating an individual that's going to be a certain type and let you have your class type, you can reference that by a label. So for example, let me go back to my PowerPoint. I'll go back to the previous slide. Say that I have a class mouse and I want to create an instance of the mouse. I could just say mouse here.
What about a privilege class?
Yeah, I will get to that. Yes.
And mouse is not in the foundry. It needs to be in your input file.
Yeah, so it always needs to be in your input file. So robot isn't going and searching the OBO foundry for these terms. It has to be in your input file.
You could use the query, you could use the IRI or the identifier, but yeah, you could use the IRI or the identifier and then robot know about it, but if you want to use the label, robot needs to be able to look up that label and match it with the identifier.
I think that's the ID for mouse. The fact that I still know that is. So yeah, you could use the identifier, but if you want to reference it by label, yes, it has to be in your ontology. And yeah, for an instance, you wouldn't put anything in the subclass column. I think robot would still create the axiom, I believe, but then you'd have both a class and an instance for this ID. So just side note. Okay, so adding annotations. So this annotation template string looks like the letter A plus the property label or ID. So again, if definition is in your input file, you can say a definition. If it's not, or you're not providing an input file, you can reference it by ID like that. And then you can also do typed annotations and language annotations. So say I wanted to just do a string, which is the default, but if you wanted to do some other type here, you can just do 2 carets and XSD string, and that just says it's a typed annotation. And then you can also do a language annotation. So that's just saying make it English. The other thing you can do is you can do axiom annotation. So a lot of the time in OBO Foundry, you will annotate the definition with the definition source with a database cross-reference, and you can do this in templates as well by using the symbol here. So this is going to say attach this database cross-reference annotation to the column to the left, which is the definition. So you have my definition, and then you can say here is the source.
Becky, one mistake I've made a lot is if you want the annotation to go onto the previous annotation, they have the columns have to be next to each other. This is a mistake I made a lot, like where I have like a label and then, or like a synonym, and then I have like another column just like for my reference. If you can have empty columns, if you have a second line is empty, it won't actually get added to the template, or it won't get added into your ontology. But if you want to annotate something onto something else, you have to have the columns next to each other.
Yes. Good call out. Yeah. So what Nicole was talking about was you can actually add your own stuff to these templates and not have it added into your ontology. If, for example, you just want to provide some notes by not having a template string in the column. So my note, an example note. So this is maybe for documentation purposes or to help other people understand why something was added or changed. This will not be added to the ontology.
Actually, just to be sure that I understood your example, the NCBI taxon should not be in the type, but rather in the parent. Because the type should be a class.
Yeah, so by putting this here, this is going to say that this term, its RDF type is NCBI taxon 10090. So it's an instance, not a class. But say I want to create a class that is a subclass of mouse, then I would put this in the parent column. And you can put owl class in the type column if you'd like, but the default is owl class. So if this is left blank, it's just going to create a class, and then it'll be a subclass of NCBI taxon 10090.
That's where you have this class, and then with the property and another class.
Yep. So I will get to that as well. Okay, so a little bit about logic. So the SC keyword followed by the little %, that's a direct superclass. And then EC followed by %, is an equivalent class. So that's how you can add equivalent classes to your row. And then this %, is actually a wildcard that's used to fill in the logical expression. So say you want to give a part to something, you start it with that SC keyword saying, I want this to be a subclass axiom. You can use your property, which again, if I'm using the has part label here, then I need to make sure it's in my input ontology, some %. So going back to my example, let's instead say, I don't know what has part mouse, but here we go. So this will create on this OB123 term, it'll create the subclass axiom has part some mouse. And then you can also use existing classes in the expression. So not only can you reference the properties, but you can reference the another class as well. And then again, the wildcard is just filled in based on the cell value. So we talked about type, but there's also class types. So say you have an expression like this has part expression, and for some of your classes, you want it to be a superclass statement. For some of your classes, you want it to be an equivalent statement. You can do that. Instead of saying SC or EC, you can just use the C keyword. And then you can also include this class type column here with the class type template string. And then you can say, I want this one to be an equivalent. So example 1 will be equivalent to has part some example 0. Example 2 will be a subclass of example 0. And if you leave this blank, the default is subclass. So this would get created as a subclass statement. And then again, just a reminder, you can reference a class or property by label if it is defined in your template and your template has a label column. So say I had an ID column somewhere else and I'm creating a new class 1. I can reference it by label here because before robot starts filling in these axioms, it'll actually look through the label column. So it knows all the labels of everything that is being added. So you can reference classes within your template, or if it's defined in your input ontology. The last common thing you can do with templates is you can include multiple values. So you don't have to include a row for, say, you want to say something has multiple parents. You don't have to include multiple rows. You can actually do that with the split keyword. And a lot of the times we use pipes, but you can use comma, you can use really whatever you want to use. Assuming it's not used within the cell values. So for example, I would not want to use a colon as a split character because then robot would split on every single colon. So pipe is usually a safe one. And then you can provide multiple values and it'll create a subclass axiom for each one of these values. And you can use that for annotations as well. So say I wanted to include multiple BBXRFs. I would do a database cross-reference split. And then I could provide and those would be created as multiple database cross-reference annotations as well. You cannot use that on the ID column. You can't use it on the label column. Those should be single values only. All right, now to the actual command, now that we've gone over what the templates look like. And again, I know that was a lot of material. All of that's in the documentation, plus how to do more things. So now we have a template in our examples directory. This module.tsv file, and we're going to create something from it. So I'm going to do template input edit.owl, and I'm doing input so that I can reference the labels used within the edit.owl file. Module.tsv. And then I'm going to use this ontology IRI keyword to assign an ontology IRI to my output file so that I can reference it in my input file. For example, if I'm creating a new module and I want to import that module into my file. So module, whatever your ontology IRI, output results module.owl. Okay, so now I can see that I have created 2 new classes that were defined in my my template. And then you can see these are just other classes from the original input.edit file that were referenced in these. So it doesn't pull along the labels or annotations for these because they weren't defined in the template. But say, for example, you just wanted to add a new class to the ontology instead of creating a different module, you can actually use this merge before keyword. So there are a couple of different merge strategies. Find it on here. So if you don't include a merge, the output is just the contents of your template. And if you merge before, so the output will be merged into the input file on immediately, so that only the merged ontology will be the output. The merge after keyword is used when chaining commands. So the result ontology is merged into the input ontology, and the output is the merged ontology. Generally, just use merge before if you're outputting the ontology. So I will go back Yeah, the reason you would want to use the merge after keyword is if you want to save the basically the results file, the contents of your template only separately from the entire merged file. And you would just go on to chain and do other commands with the entire merged file. Template, new class, I'm just adding one class, and then I'm going to merge before output results new class dot owl. So in my new class template, I only have one class defined. I'm creating this class liver, but when I go and open results new class dot owl, it is my entire input ontology plus the new class liver. So that adds the contents of the template into your ontology. One thing to note, if your ontology does have import statements, you want to make sure to use collapse import closure false with any merge option. Otherwise, those imports get merged in. Yes. Mhm.
So we can split multiple cross references, which I believe is an limitation. Does that go for data properties and object properties?
Yep. Yeah. You can use split on any of those.
Can you add more columns? Or is it it just has to be the ID and then just one of this kind of split state?
Yeah. So say I wanted to do multiple as part.
Mhm.
It's the same thing. So then that would create two subclass statements. Has part some example 0 and has part some example 1.
And if I want to add another column, that's let's say has connection. I'm just making this up, right? And then I want to add another column to that input file with that. And has connection and then split, have multiple has connection properties for the same.
Yep. Yeah. I'm not very good with PowerPoint, or I can't figure out how to add another column, but yes, yeah, you can do that. You can do it as many as you want.
Back to equivalent classes.
Mhm.
You support object intersection?
Yep.
Okay, so in my equivalent class, if I have object intersection and I can have 2 things or 3 things or 4 things in one intersection, how would that look?
Okay, so say you define this and say you just want your class to be equivalent to the intersection of 3 other classes, right? Robot will create this as the intersection of everything defined there. It won't, when you do split or multiple equivalent classes, like say I have multiple columns with equivalent classes, then it creates an intersection of those. And then you could also do a Manchester expression within the cell. Okay. So a little bit more, another way you can create content or add content, you can use Sparkle queries as well. So you can use a construct query or you can do a Sparkle update. I think I only have 5 minutes left, so I'm going to try and breeze through this content. So just a construct query, instead of outputting, for example, a table of results or true false from an ask query, this actually outputs RDF data. So here, my construct query, actually, instead of saying like output.tsv, I'm outputting a turtle file, and you can specify the output format of the constructed module with the format keyword.
If you want a few more minutes, that's fine.
Okay. I think we're getting closer to the end. Template was the biggest one here. So robot query input edit.owl, and then I have my construct query. And I could and result. So really quickly, I'll show what the construct query was doing. So all this construct query was doing was taking the terms with the label and definition in this particular namespace, the Overton namespace, and constructing a new module. So containing all the labels and then all the definitions, but using a different property for definitions. And you can see there's nothing in here because I did not do the class assertions. So you do have to, this is only annotations, but you can see, so that was my mistake on constructing that module. But you can see there's the subject and then the annotations on here. So that's one way to create some new content. You can also update existing axioms with insert and delete. So here I want to update some existing annotations. And then my query is down here. So I am replacing all references of definition with this prop 1. So I'm just going to change the annotation property essentially. So for updates, it uses a different parameter, a different keyword here. Instead of saying query, I'm using update, and it just accepts the Sparkle update. And then this actually uses the output here instead because we are updating our input ontology. So update can be chained with other commands as well. And I'll get to chaining commands in a minute. I know I keep referencing it. We will talk about it, I promise. So I'm not, just to save some time, I'm not actually going to demo this one. Just know that's something you can do. You can run Sparkle update queries, which actually update the data in place. Okay, I may need to skip this section because I do want to get to chaining commands, but there are a couple of commands for reusing other ontologies. So extract is a major one for creating subsets of, for example, external ontologies. When you don't want to import the whole ontology, you just want to reference a couple of terms from it, you can create a smaller module of that ontology using the extract command. And we support a couple of different methods of extract. There's the SLME method, so syntactic locality module extractor, which is good if you want to preserve the logic in your in the input ontology. So it will not only include the term, but also all other terms that are used in the logical definition of that term, and it expands outward from there. So for example, all the logical definitions for this one, and then all the logical definition terms used in the logical definitions of the terms used in logical definitions of the term, and so on. And there are a couple of different SLME methods depending on what you want to get. So the this we call the seed. You can provide a single term, you can provide multiple terms, or you can provide a file of terms. So the bot, which stands for bottom module, is a seed plus all the super classes. So that's saying start at the bottom and work up. You can also do top, which start at the top and work down, or star, which is just the seed and all of the interrelationships. Star will end up being smaller than some of the other ones. Sometimes it can vary. There's also myriad, which is a little bit simpler. It only preserves the subclass hierarchy. So you won't see the logical relationships, only the subclass hierarchy and the annotations. And I just want to call out really quickly here, instead of input, I'm using input IRI, which you can reference a file as long as the IRI resolves to that file, which for all the OBO Foundry ontologies, it does. So robot can reach out into the world of the internet and pull that file in using input IRI instead. And then one difference for all the SLME methods, you specify the term, which is the input term. And for Myriad, you actually can specify upper term and lower terms. This should just be term, not terms. Or oh wait, no, that is correct. So if you want to specify a term by ID, you say term. If you want to specify a term file, you can say lower terms. That's the bottom. And if you don't specify an upper term, it'll go all the way up to owl thing. If you do want to cap it at a certain term, then you can specify upper terms. And I'm sorry, I'm speeding through this. I am happy to answer any questions about it later on. Okay, so managing ontology releases with robot. So creating a release version of your ontology. There's the merge command, which you can merge two separate ontologies together, two input ontologies, and get the output like that. Or you can merge the import statements. If your ontology does have imports in it, just inputting the ontology itself alone into merge will merge all those imports together. And as I mentioned before, if, for example, you're merging two separate files and one of them has import statements and you don't want those imports to get merged in, you need to make sure to include collapse import closure false. Otherwise, they will get merged in. You can annotate your ontology. So this is adding ontology metadata. So you can add a version IRI, or you can add other annotations to your ontology. For example, a date. So that's what we'll do here. This gives it a version IRI, and then it adds a date to the file as well. This is all the ontology header. This isn't terms within your ontology. And then finally, we get to chaining commands. So robot can chain one command to a next. Only the first command needs an input file. And then you don't need to specify outputs for any of these steps until you get to the end. You can if you want to, and it'll spit out intermediate files. But essentially, it'll perform the merge, and then it'll pass the output of this merge to reason. And then it'll take that and then output the next one to annotate. And then finally, you can specify an output. And that is the combination of all the commands together. So this is really good when you have multiple steps in your workflows to put commands together. So you're not creating all of these intermediate files that you don't need. For releases, one common chain of commands is the reason, relax, reduce chain to create a complete and non-redundant subclass view of your graph. So we talked about reason. Relax will relax equivalent axioms to subclass axioms, and then reduce removes redundant subclasses, which may be added by either reason or relax. So that's a pretty commonly used one. One more thing I want to talk about, ensuring your ontology aligns with OBO standards. We have this report command, which will run a series of standard checks across your ontology. So what gets checked? Ontology metadata. So those annotations on your ontology header, there are some that we require as a part of the OBO Foundry. So it checks that these are all there. It also checks annotations, make sure everything has label, definition, there are no duplicate labels, no terms have multiple labels, that sort of thing. And then just some logic stuff. If there are any missing superclasses, if there are one-to-one equivalent pairs, that may come up as a warning, because that is often a sign that's not always incorrect, but it can often be a sign that something's wrong if you have a one-to-one equivalent, like this class is directly equivalent to this class after reasoning your ontology. So report is just same input, output. And then this will fail if there are any error level messages, but you can also change that and say, I don't want it to ever fail, or I want to fail on a different level. I won't talk about these other checks you can run on your ontology. All of those are in the documentation though. Okay, so what's next? Explore the docs, ask questions. We are on GitHub, ontodev/robot, and there is also a robot channel on the OBO community Slack.
The Java library is available.
Yes. He had just asked if the Java library was available on Maven, and it is. I don't know if that's. I will have to. There it is.
Sorry, just one more thing on that. It's packaged as a library and a command line tool, so you can use all of these operations from any JVM language, execute them. So it doesn't have to be used from the command line, but usually you do.
Yeah.
On that note, what's the status of robot Python integration? I've probably asked both of you this from time to time, and I've tried it, but is it a realistic approach for me if I prefer to develop in Python, but I want to use some of these things? Is that something worth pursuing? Have there been any developments in it over the past year or two?
Yeah, I'm assuming you've used the Python command.
Yeah.
This is kind of where a robot in Python is right now. That you just need to use this Python, and essentially there's a gateway, so you still have to have the JVM running, and then Python can attach to that gateway. In robot, there have not been any further developments with using robot from Python.
Now, aren't there two different modes for launching the connection between?
Mhm.
That was always.
Yeah, it's a little weird. So py4j has this launch gateway command, which will start it based on the jar path, or you can launch the jar first, and then you don't need to launch the gateway. I'm happy to sit down and talk to you a little bit more and show this. Yeah.
I'm not aware of anybody really using it for real. So if you do, yeah, let us know, and you can talk on the robot Slack or something. But yeah, you always have to be translating between like the Java documentation and how Python calls things. I think that's what slows people down, and then the actual like making sure you have two processes running where things are in one place. In the tools workshop this afternoon, we're going to have a bunch of stuff on using ontologies from other languages like Python non-JVM solutions. That's our first session. I will be on Java. That's the title. Anyway, so come to that and we'll talk about some other alternatives.
Yeah, that's why I wanted to be clear. There hasn't been any robot development, but that doesn't mean that there aren't options.
Thanks, Becky.
Thank you.
All right. Do you hear me well? Not yet. Can someone confirm that my voice is coming through?
Yes.
Okay, great. All right. So we changed a little bit the order of the two things I wanted to talk about. So I'm going to start now with talking a little bit about the ontology development kit, and do the parts on like the more general part on open science engineering a bit as a last 10-minute thing in the end of the tutorial. So one thing for Nicole and James, please just take a little bit to look around and just interrupt me. Just speak up when someone wants to ask a question, because it's very difficult for me to look at the chat and talk here. So just say, please, Nico, can you just answer? Just interrupt me in the middle of what I'm saying. It's not a problem. All right, let's get into it. So lots of what we are talking about here in the context of the Ontology Development Kit will relate a lot with the stuff that you've heard so far. But I will also share with you some of the resources. You will not be able to follow along this the demonstration that I will do. It's going to be a little bit quick. I've decided this year that rather than showing one small thing slowly that you can follow along, that I will give you a bit of a broader picture of the workflows that you can achieve with the Ontology Development Kit, so you get a better understanding about the potential. And that is going to be a little bit fast, and I hope, yeah, it will work without any issues. So just briefly, as a reminder, let's dive right in. The goal of ontology engineering, okay, you could phrase it in many different ways, but in general, is building a knowledge base or some kind of classification that captures all relevant concepts of a domain or for a particular use case and their relation to other domains in a scientifically accurate and logically consistent way. So in particular, when we are writing logical definitions, we need to very often reuse entities from many different ontologies. So this is an example here where we want to define a phenotype term in the human phenotype ontology called hypolysinemia, and we want to define it in terms of a quality from Pato, decreased amount, a chemical entity from Cabby, lysine, and a anatomical entity, the blood in Overton. So these kinds of, this is actually a very simple logical definition. And if you look at some of the ontologies that are already out there, like, for example, HPO and OB, we've mentioned it before, you will see considerably more complex logical definitions in these ontologies. This is just like a small, an easy example for you to get a sense and just to get for me to get across some principles. So some of the questions that in the context of the Ontology Development Kit, and I will tell you in a second what this is, but in this presentation that we want to answer is, for example, how do we get terms from external ontologies to reuse them? So Becky has already explained how you can use robot to extract terms from other ontologies. And what we will talk about here is how this will fit into the more overarching workflows of ontology management. Another thing that we want to answer is, how do I make sure that when I make a change to an ontology, I didn't break anything? So in particular, because we have ontologies that have a lot of different projects and a lot of different contributors, it's absolutely important that we know that when they make a pull request and before we merge them, that some kind of checks are being run. And Becky has introduced, for example, robot report as one important component of quality control checking. But and here we will integrate robot report with other things into a wider continuous integration testing system. And lastly, how do I make sure that all users can access the ontology in a standardized and fair manner? So let's say you all become expert at robot. This doesn't automatically mean that you will all run the same exact processing steps on each ontology to make sure that they have the same kinds of metadata, like, for example, the same formatted OWL version string or the same version IRIs or various other aspects. So this is another kind of big aspect, like how do we not just execute workflows that we define in robot, but how do we unify workflows across many different ontologies? So what is the ODK? So the ODK, generally, when we talk about it, we separate two pillars. So the one thing is the ODK is a toolbox. Okay, so just imagine it literally as a toolbox. So the ODK has all of the kind of tools inside of it that we generally use to perform ontology workflows in most of the kind of OBO and OBO adjacent ontologies. Like, for example, robot, which is obviously the most important tool in ODK, but also other upcoming tools like OAK, about which you will hear more during the ontology tools workshop later. but also just more simple things like a standard shell with a bunch of shell command line tools, other tools like fast OBO, maybe we will hear about that during the ontology tools workshop as well, other reasoners that are not in robots, and many other tools, like lots of Python tools as well. So it's a big toolbox which has all of these things in it. And basically what you need to do in order to have access to all these tools is, rather than to install them all one by one, you have only Docker installed in your machine. You run docker pull OBO library ODK full, which installs the ODK, and then you basically have a Docker container or a Docker image that you can launch, where you can launch a Docker container that has all of these tools in it. So, for example, we had some trouble here before with someone setting up robot on Windows, and in some cases it helped for some of the collaborations we had with Windows users to simply install ODK, and they would use the ODK container so they would enter the ODK container and be able to launch robot commands from in there. So that's like the toolbox aspect. And the second aspect, and the aspect that I want to focus on today, is the aspect of workflow system. So Becky introduced all of these different workflows that I would refer to as atomic workflows, like how do I extract a term from an ontology? How do I run a query? How do I execute a check? What ODK tries to do is integrate all of these workflows into larger, consistent and shared workflows that can be used across ontologies. For example, we can use this to standardize these release pipelines that Becky was mentioning, with like relax, reduce, and reason, and provide a standard workflow with a robot chain that everyone would use exactly the same. All right, so let's go a bit into this. So now let's talk about ODK specifically. So what is it? How does this workflow system manifest itself? So the workflow system is basically manifested as a Git repository template. So you use the ODK to generate a Git repository, and I will talk about this in a second, but because it takes about 4 minutes to initialize a repository, I'm going to show you first how to do this, and then I will explain what is actually going on. All right, so I'm going to, I'm just going to increase the font even further. Hopefully you can see this a little bit. So I'm going to create a new directory. I'm just going to call it ICBO. And now what I will do is I'm going to download a predefined configuration file from my ontology. So again, as I said before, I'm not going to go in a lot of detail here about how ODK exactly works. We have very detailed tutorials that bring you through this like initial parts of the process, how to configure your repositories and how to set it up. We're not going to discuss this today. Today is about looking at the whole picture a little bit. So I'm going to download this this configuration file. I'm just going to take a look at this. So here you can see this configuration file. This is basically a configuration file for the creation of a cat anatomy ontology. I'm just going to say this is a cat ontology without saying anatomy. The only change I'm doing now, this is important so that later on some features of the ODK actually work, like the automated documentation system. I'm changing the GitHub org to my own, and I'm changing this here to cat tutorial ontology. Oops, tutorial ontology. So this is the name of the GitHub repo under which I will deploy this in a second. Just briefly, I specify here that I want to have these release artifacts, base and full. Base is a release artifact that James hinted at before, which just only contains the axioms that actually the editors curated. Full is the full ontology release merged with all imports, and then there's a simple release. Then we have a bunch of different export options here to say, I want this exported as OWL, OBO, and JSON. and I've specified some imports. So in this case, I just want to import RO and COP. So that's all I want to say for now. This is the configuration file, and this is how you would start building a repository like that. All right, so now I'm going to yes, I'm going to create an initial version of the repository. I told you this will take 4 minutes. I'm going back to the slides now, but just so that you see what happens inside of this pipeline here, you can see in this report that some files are being created. So a repository layout is being created. So I'm going to jump forward. Oops, that's not the correct one. So I'm going to jump here to the back to the slides. So what will happen now is that the ODK creates this repo layout. It will create release files, templates, such as the ones that you see here. So this is, it will create, for example, the primary release of the ontology in OWL, OBO, and JSON, then the simple release as we have configured it, the base release, and the full release. It will create a editors file that will be edited, for example, by your curators in Protege or in whatever other tools. It will create a template for the imports with a terms file and an OWL file, and all of this in the beginning will be empty. So what happens now with this repository, and we will go through this once this is done, is the ODK will actually initialize a Git repository entirely. So it will commit all of these files into a finished Git repository, and then we will push this Git repository to a social, let's say, Git version system like GitHub or GitLab, and then we will integrate some of the functionality of that we have with the workflows in these systems. So, for example, we have the ODK comes with a bunch of pre-defined GitHub and Travis actions that can be used to automatically check the quality of your ontology, and we will show you how this goes in a second. And we have a bunch of preferences of how we design our social workflows, like how do we open a pull request and have our GitHub actions testing our ontologies each time we open a pull request, and so on, and providing other executable workflows. Let me take a quick look how far we are. Still not quite there, so just annoying why this keeps switching to the other window. All right, so I'm going to slowly descend forward while this is still building. So the first workflow that I will introduce in a second is the general imports workflow. As we've hinted at, it's implemented using robot, of course. And the idea is you have, once you have your repository all together and you want to import a new term, you just specify, I want to report this new term in some file, and then you type a command, refresh Overton, for example. This is the example from before where we edited the human phenotype ontology to add a definition. We needed this term from Overton. Then we run refresh Overton. The ODK has a workflow then that uses robot to access, to first download the Overton ontology, and then extract a module from Overton, and then link this with the editors file. So the idea, and that's kind of like the thing that we try to promote strongly across OBO, is that we really want to move away from this kind of semi-stale import system where, for example, you copy-paste terms from an ontology into your ontology, and that is the import. And we want to move to a system where we dynamically import terms and refresh them all the time when they are being updated upstream. So we always have the most recent labels, the most recent definitions, and the most recent axioms when we pull them in to our ontologies. And we also allow, like, of course, the configuration of exactly what kind of module we want to use, depending on the kind of use case we have for this particular import. All right. Hopefully now it's done. Yeah, that's great. So this is we have now created the repository is completely finished. I'm going to add, so as you've seen before with Nicole, we are using GitHub Desktop everywhere. It's quite convenient for working with anything related to GitHub. So I'm going to add this new repository that we've just created here to the GitHub Desktop. Okay, add repository. All right, so you can see in the history there was an initial commit, and we even ran an empty kind of release. So this is what the ODK does when you first create a repository, and we will just now create put this repository on GitHub. I'm just going to quickly go back to copy whatever name I used here, cat tutorial ontology, and name it such. And also for those who use this tool, this is by default making it private. I'm going to make it public so that we can run our GitHub actions and so on. And as organization, I choose none because that is going to put it into my repository, my personal user repository. So it's going to publish this ontology now. Okay, so now if you go to GitHub, this is the repository that we've just created in a few minutes, which has all of the kind of base files here. It even comes with things like a contribution guide, which is based on OBO principles, with a code of conduct, with a bunch of predefined GitHub actions, editors files, imports files, and so on. So we are not going into much detail here. Just want to say it has been created. All right. So now the first thing I just want to do is show how the import workflow works. So I'm going to going into that directory now. One moment, and I'm going to open the COP terms file. So there are various ways to add a new term using into your ontology using the ODK. I'm using the simplest one now, so I'm just gonna go here and go copy this from here, from the ODK tutorial up here. So that we want to import the term COP 82, which is planned process. Okay, so I'm going to add this to the terms.txt file. And now I'm going to use an ODK workflow, which is refresh COP to pull this term in from a fresh copy of the COP ontology. So you can see here what happens in the background. None of this ever will, you will never, as a user, a normal user, you will never care really what happens here in detail. But what happens is that the COP ontology is first downloaded. And then then here you can probably recognize the robot commands for extracting the a module from COP using a robot chain. So let's look at our Git diff. I know that this is probably quite small. Unfortunately, I don't know how to make this here bigger. Is there a way to make it a bit bigger? Zoom in. The text here, I don't think it will get much bigger. But what you see here then is, okay, a lot of things have been pulled in. Yeah? So this is what Becky hinted at when she was talking about the different module extraction techniques. So this here is the syntactic locality-based module extraction technique, in particular the bottom module, which is the default in ODK, and it has pulled in a lot of classes, although we wanted only one. But today we are building a more application ontology. So we want to only import just this one term that we have added here. So what I will do here, so I'm going to show you real quick how you can simply change the module type. I'm trying to change it to filter. So hopefully, is this still the correct one? Yes. Oh, no, it's not. Not get confused here. Answer. Okay. I'm going to change this module type here. Okay, now I will run. So now what I have to do is I have to update the repository configuration, because I said now I don't want this workflow. I want to change it. So I have this update repo command, which will update the repository configuration. And just for you to show what happens. So first of all, some documentation is updated, which now says that this cop module is actually a filter module. And also the make file will have a new goal in it that that overrides the standard goal that is syntactic locality based into a robot filter module. Okay, so let's refresh the cop again. Obviously, we don't have to mirror it, but because cop is so of every time if we don't want to, but because it's so small, I'm just going to do it. The cop ontology. So now I've refreshed cop again, and we can see that where are we here? That now we actually only import this one term. So we moved from one module extraction technique to another. Different use cases. We're not discussing this. I just want to show there are different ways to configure this import pipeline. All right, now this is now. Nicole has showed you a little bit how this worked before. So now we are just going quickly through a normal Git editing workflow. So let's say your use case is you wanted to import this term, you're done. Now you want to make a pull request. So I call it cop import planned process. I'm committing all of the changes. Add planned process. And now I will go and make a pull request with these changes to my Git repository. And what you can see now, I'm not taking great care here about making beautiful pull requests, but you can see what happens here now is that the ODK quality controls checks are kicking in. So I'm just going to show this a little bit, what's happening. So this is a GitHub action. This is automatically executed by GitHub. So when we configure a workflow, and this first does a bit of installation, installing the Docker container, so the ODK Docker container, then checking out the repository, and then running actually the quality control checks. So these quality control checks, I hope it comes quickly now so that I can actually show you some of them. Maybe it's it will come in 2 seconds. I will show you in a few minutes. So this brings. So I should have come back to these slides anyway. So this is just an enactment. This is of this figure what we just did. So the developer made an edit, made a pull request, and now they want to be convinced that they did not break the ontology. They want to get over their fear of breaking stuff. So what we do is we run this continuous integration check framework, which is a combination of many different, mostly robot commands, like for example, robot profile validation, some custom validate Sparkle checks, and robot report. And these are all being executed now. Actually, it was super quick, so it was already done. So let me show you. So you can see here there are some Sparkle checks, some robot report commands that are being run, and then the pipeline says success at the end anyways. So now going back to our pull request, we would ask for some other reviewer to have this pull request reviewed. They would confirm it, we would merge it because CI is finished, and we are done. Okay, so this was basically just a walk through the continuous integration part of the system. So all of this is part of the ODK repo. Now I'm going to go back to the main repository, to the main branch, and pull the changes that have just merged into the main branch. so that I have them in my local repository. And now, so let's go back to the slides for 1 minute. So now we have done our edits. We have done our imports. All of this is great. And now we've decided that it is time to run a release. Okay, so what the ODK does is it implements a bunch of standardized release artifacts, like the full release artifact, base release artifact, and a bunch of definitions for ontology subsets, like a human view of a metazoan anatomy ontology, for example. And it defines a bunch of standard serialization into OWL, which is RDF XML by convention, OBO format, JSON, Turtle, and some others. So you basically just configure whatever you want to be exported. You run the prepare release workflow, and then the ODK will generate all of these files with standard serialization, standard versioning properties in it, and thereby, you know, enabling this kind of separation between the editor's environment, where you do your edits and you do your where your curators do your edits, and all of the stuff that is released to the public. Obviously, it's all fully customizable. If you want release variants that are non-standard, you can just define them as part of the ODK process as well. Okay, so let's just quickly run a release. Make prepare release. I'm going to run a fast release. So a normal release will actually make sure that your terms are still up to date with the imported ontologies. We just want to quickly run a release, and we are sure that we are already up to date. So I'm running the prepare release fast process, and this was so it's generating now all of these artifacts we talked before, the different variants, the different serializations. And you can see also here the version IRIs being added and the version info tags being added. And in the next version of ODK, actually, you can also configure your own base IRI. So if you're not OBO or something, you can still use this system here in exactly the same way with your custom IRI settings. Okay, so now we see all of these updated release artifacts. We see, yeah, our planned process class is added to the OBO file, to the OWL file, to the JSON file, and so on. So now I'm going to do something bad. I'm going to bypass pull request just because of time limitations. I'm just going to commit these changed release artifacts to the main branch. We never commit anything to any main branch under no circumstances during real operations. So I'm just going to push them up and go back to the repository. So now we have generated all of the release files. And so the last step, which is not related to ODK, but it is kind of like the convention that many, but by far not all of the ontologies are following, we now create a formal GitHub release. So we just go to the GitHub release, create release tag, create a new release. The only thing we want to make sure we do is to make sure that we are sorry, using the correct version tag here for our version IRIs. So this is a V with the year, month, and date. I'm just going to create a new tag, and everything else here is up to you, whatever you want to put there. So I'm just going to write September release. I'm going to use GitHub's awesome function to automatically generate release notes. And then I'm just going to publish a release. So done. So now you have both, you have generated standard version artifacts that are stable for the rest of the existence of this repository. You have done a release, which means that you can access each and every version using a versioned URL. And if you're in OBO Foundry, even a versioned persistent URL. And yeah, so that's that takes care of this part. So this is yeah, this is how this piece of the workflow works. All right, last piece, automated documentation. So obviously, all of these things are quite complex. So you have to think about many things like refreshing your imports from time to time. How did the release work? And oh, my custom ontology has some specific exceptions that I need to run before a release, and. So it can become quite complex. So what we are trying to promote is to use and really thoroughly document these workflows for each and every ontology. So what we will see in the last talk in the end a little bit is how many different organizations start collaborating on the same ontology. It is absolutely important to document all of these workflows very, very carefully. Okay, you add getting started guides for new starters. Like, it's, I think, the most important artifact in that any ontology should have is a contribution guide and a getting started guide that explains to some new person, this is how this works, this is how you make a contribution. Provide detailed documentation on how the workflows work, document design patterns, and provide even some user documentation. So the ODK will automatically generate a pass at a documentation system. So let's look at, sorry, I needed to stay in here. Let's look at this real quick. So the only thing I have to do now, so because the ODK has already generated the documentation system in the very beginning for us, the only thing I need to do is in GitHub, I go to settings, go to pages, and here in the build and deployment section, I just say, use the GitHub pages branch, and there use the root directory. So here I press save. Now what happens internally in GitHub is that GitHub is informed, you want to deploy your own custom documentation pages? Awesome. So what it has is, this is a GitHub action here that is internal to GitHub, and what it does is it follows these instructions and now deploys a website on some web server in the GitHub world with all of this documentation associated with it, and make it accessible via a standard URL. So it takes around 30 to 40 seconds. So hopefully it will be done soon. Now it's done. Okay. So now I'm just going back to here, because back to the settings pages section, because we can see here now there is now a new thing at the top which says your tutorial pages have been deployed. You can click on that and you see, awesome, my own guide for my ontology is fully deployed. It already recognizes what's the latest version of the latest release version and all of that kind of stuff. There are some standard ODK guidelines, like how to do a release, how to refresh your import, some other information in here that you can look at by yourself. And yeah, so if you want to do a change, so I'm just going to quickly just do a random change to the documentation. Please reach out on the issue tracker. Okay. So now what happens, I'm not going to wait for this, but just so that you understand the system behind this, is what happens is that the ODK goes, rebuilds all of the documentation pages into HTML. This is what the docs workflow does. And when this is done, the GitHub is informed and will redeploy the page to where we looked at before. Okay, so that is kind of like how the system works. All right, let's go back here to finish the presentation. Yeah, so we've talked about ODK being a toolbox. We've talked about ODK being a workflow system that enables you to manage larger workflows, like managing multiple imports, your release pipelines with standardized release artifacts, managing standardized documentation pages that you can, and all of this, of course, customizable, and having a continuous integration testing framework in place. So all of these things you basically get for free. And we will talk a little bit, I think, during the ontology tools workshop, how we think that fits into the wider scheme of the tooling world. Great. Yeah. So first, I think, yeah, I'm exactly in time. So were there any questions by anyone? If anyone wants to ask anything? I can't hear anything, but so someone has to unmute something. Still can't hear anything. No, I can't.
Hopefully no.
Okay, so the finished product usually we look at in Protege, right? If it's an out file. And
yes.
So I see a lot of go here, go there, click here, go there. And I would be, if I was a manager, I'd be very nervous to give a PharmD something like this.
Mm-hmm.
So, and as a developer, I've worked with tools that are homegrown that link into Jira and GitLab that do source control. So my question is, why not develop a Protege plugin that works with Swing?
So first of all, just to address the click here, click there comment, you have to also remember is what I showed here now is how to set up this whole system in 30 minutes, not how you use it. So this is all these like clicking back and forth was also because I had to show you these are the process, these are the steps you have to go through when you are setting it up. But you're right. Of course, you still have to, there's still some workflows that you need to run, like, for example, refreshing the import. So if you want to refresh the import, you will run a refresh import command. And yes, actually, this is a great question that James will answer maybe a little bit during the ontology tools workshop, or if you ask him later, there are UIs that that can do all of these things that we've discussed here where you can have like a web UI and you can just click on buttons rather than running anything on the command line. Protege itself is by far not flexible enough to deal with all of these this complication. So you have to think about how do you standardize and update your repository? You know, like these things change over time. How do you make sure that we synchronize the most modern workflows for importing ontologies every year when they update? How do we synchronize with the latest tools? And you probably use Protege know that it's not exactly updating very often. So all of these things, like it doesn't fit exactly into the Protege into the Protege plugin, let's say, idea. I think it's outside of it. Protege is the tool to edit and curate the information. ODK has nothing to do with that, but you have like a workflow system around it that manages all of the standardized processes.
Okay. Any more questions? All right, you can go ahead with the next section. Okay.
All right, I will blaze a little bit through this. It's timed for 15 minutes, but I will make it a bit fast. So usually during past ICBO presentations, we have put a lot of emphasis on like technical skills and tools. Recently, as part of OBO Academy work that in particular Nicole and I are spearheading, we are also putting a slightly bigger emphasis on like the social workflows around these tools. So what I'm going to talk to you a little bit about, at least for 10 minutes, is about the idea of open science engineering and how you can improve your own skills in this area and to improve the whole interconnected network of open science projects. So first of all, open science, as you know, is a catalyst for tackling global change, like problems like rare diseases and pandemics and climate change. These are all problems that many of us are involved in. These require a lot of global coordination. And open data with suitable licenses is exactly there to help addressing these issues. And there has been a lot of progress made on this front. But the problem is open licenses are only a small part of the answer, or a part of the answer, and the really hard part, and that's what James described in his talk in the beginning, is actually how do we standardize the data to enable their integration. So James described a lot this problem with of using standard vocabularies before. And if you attended yesterday's LinkML workshop, you might have talked a little bit about semantic data modeling. So basically, non-standardized data without explicit semantics is not really open. Yeah? If you just dump a huge heap of data publicly available on the web, this doesn't mean it's open. Even if it's publicly available, because no one knows what to do with it. So ontologies play a central role in this process. I'm just going to, you know this a little bit already from the talks before, so I'm just going to say for reasons like data standardization, capturing domain knowledge with well-defined semantics so that we can answer questions like, is the heart part of the cardiovascular system, or is Friedreich's ataxia a genetic disease? Building data analysis pipelines to allow corresponding analysis and aggregation, like which patients had a disease of the cardiovascular system, or which patient had a genetic disease, and allow things like data validation. So does it make sense if my graph neural network application predicted that my patient may have prostate cancer if they are female, for example? So in order to fulfill all of these kind of different roles in the standardization efforts, ontologies must be community driven. So this is just a use case for a simple example from how Overton evolved in from 2009. So in the beginning, it was basically Chris Mungall with a bunch of people around to create a first version of a pan species or metazone anatomy ontology. And then after a few years, they all came together into the same organization. Monarch initiatives and other organizations like Phenoscape also became interested in curating Overton. And then by now we have a lot of different projects and organizations involved, like Human Cell Atlas, HapMap, and Single Cell Expression Atlas, and so on. So there are many different organizations. And the thing is that with so many different organizations, it is, and that was a great question that was asked in the beginning, how is this stuff coordinated? These are hundreds of thousands of terms, or in this case, tens of thousands of terms. How is this really coordinated? And it is tough. So you have groups saying, I want these terms, and other groups saying, these terms don't make sense. They shouldn't be in this ontology. Some people saying, is the nipple is part of the mammary gland. Other people saying it's not. Some people saying that the interstitium, this was a big story in 2018, is an organ. Other people say, should it be an organ or not? So it's really tough environment, and this environment needs to be coordinated in some way. So the persona of the open science engineer that we propose here is the open science engineer contributes to the collection and standardization of publicly available scientific knowledge through curation, community coordination, which is what we are focused on here, and data ontology and software engineering, so the stuff that we've discussed previously. So this is very early stage thinking, but 3 basic principles for community coordination across interconnected world like the biontology world. We will talk about the principle of collaboration, of upstream fixing, and of no ownership. And just so that you know, all of this stuff is in more detail available in OBO. There's even a recording that you can, for a longer kind of course on this, informal, performed by the Monarch Initiative, which you can find here also in OBO. So the principle of collaboration, we're just going to give a hint at this a little bit. Some of this seems super obvious, but it is very, very difficult in practice to always adhere to these high standards. So when we are dealing with other people, it is very important to remember that these other people are people, and people are fueled and driven by things like appreciation and attribution. In all these years we are doing this work, we see so much so much like negative and aggressive behavior on issue trackers, and some of it is just not intended. And here, basically, one of the things that we try to teach the newcomers to our community immediately is some basic things that you can do to make this better. Like, for example, never, ever, ever close GitHub issues on people without explaining exactly how they are addressed or why they cannot be addressed. They see this all the time. Community opens tickets, person closes the ticket, no comment. This is absolutely impossible and it should never happen. Other things are, this is not so brutal, but some community member comes, makes a pull request, but there are problems with it and it needs to be fixed. And you are like, it takes too long. I'm going to redo this pull request and do it by myself. Do not do that. Help the person to fix their own pull request, amend the pull request they put there, but let these people be part of the Git history of your project so that they also feel a bit connected to the work that you're doing. Also, be overly generous with likes. If you see something you like it. So we are all people, we make comments to each other, and we all have the super tough job to curate our ontologies, to standardize the knowledge in our domain. And it is sometimes very lonely job if we don't get some kind of recognition for the stuff that we do. So if you come across something that you like, just put some nice smiley or a like or even an appreciative comment on it. This is much more important. It sounds cheesy, but it is super important. We talked about a bit about documentation. I'm going to skip over that. It's absolutely essential if you want to manage such a huge collaborative effort that you constantly improve documentation. This is OBO. This is the ontology specific documentation. Otherwise, it won't scale. And we always have this philosophy. We try to reduce the work for other people as much as possible. Clear pull requests, clear comments, well formatted, and we give some good examples in the more large parts of the course. And lastly, we want to promote open communication. Do not, for any ontology-related communication, use things like emails or even avoid Slack. I'm probably doing this wrong also very often. The more is openly available, the more other people have access to the communication you have about problems, about discussions, and you should always try to promote stuff as open as possible. All right, just need to think a bit. We have like 2 minutes left. The idea of upstream fixing. So we've hinted at the fact that our domain is like very interconnected. You have a tool like or a system platform like Open Targets, which is for drug target predictions, presenting information that is based on an analytics pipeline in IMPC, which is fueled by information provided by the Monarch Initiative, which is in turn gets their information by an integrated phenomics ontology, which imports a bunch of ontologies that also import other ontologies and are based on certain kinds of infrastructure. So you can see this is like a tiny snapshot of this domain, but there's already lots of interconnections. And if something goes wrong here in Open Targets, a user comes and says, this is a bad result, or I don't want to see this. And many people do this, for example, when they, in an ontology world as well, when they see an unsatisfiable class coming, when they refresh and import, what they do is they fix the problem at the source. So they fix the problem where they are, make an exception in their code, and then that's it. So the user won't see this, but the cause of the problem, which could be a broken logical axiom somewhere down this chain, has not been addressed. So one of the big principles here of collaboration is do not hot fix information that has its cause somewhere else. Always push your issues up further upstream, as far upstream as possible, so that they can be fixed at the source. Okay. 1 last minute. I'm going to skip the principle of no ownership. Unfortunately, you have to read about it. It is about developing a mindset that we all own every openly accessible biomedical ontology, and that we should generate a more community-driven mindset when we are editing them and not have too much like this ownership issue with them. Interesting subject, but no time for this. So I just want to leave this conversation now with like the first steps to get into this mindset. Make sure you have, of course, obviously a GitHub and Stack Overflow account. Start by liking and upvoting issue comments. and that with answers that are relevant to you, complete a basic ontology contributor training like the one that Nicole has showed you before, make a pull request, even if it's just once on an open biomedical or biological biomedical ontology and see what happens, and learn robot. That's it. Thank you very much for listening. And yes, unfortunately very late, but if you have questions, let me know.
I just want to mention one thing, if you haven't already, that there is a governance and operations meeting. Did you already mention that at the beginning? Okay, so it's at the end of the conference. It's the last day, it's the last thing we're going to do. We want you all to be there, to contribute and collaborate in the principles and everything else that's going forward. So please feel free to join that. And there will be another session in the US CTS too. So please be part of it as much as you can.
Thanks. I pasted a link to a feedback survey into the Zoom chat, and I can put the link up on the screen. It's really short. Just if you have any feedback about this workshop, we'd love to hear any positive or constructive feedback. And also, there's just check boxes of recommendations. What do you want to hear next year? Because we've been doing this every year, so we'd love to know what works, what doesn't work, what are you more interested in hearing. So if you could give us any feedback, we'd appreciate it.
That's where the student that's where that's the pathway. Yeah, possible. Kind of like a, I don't want to speak.
Okay. Right. Are we good to start? Right. Are you ready? All right. Thank you, everyone, for joining us again for our afternoon session of food ontology. Here's Damien ready to lead us once again.
Okay, thanks, Anthony. Okay, and we are recording. So welcome to the afternoon hackathon food process hackathon, ICBO 2022 in Ann Arbor, Michigan. We have a number of people online and in-house, and we're just coming to the point to talk about whether we can do some breakout groups here. Who wants to step forward and participate in a group activity to help this food process model forward? And Tarini, you're online, are you? Okay, Tarini is not yet online. I'm sure she will in a moment.
I just wanted to double check on something. If
okay, I will just drop her a line in a moment. But so I'm thinking I haven't really engineered or tested out the ability of a hackathon to happen with remote participants.
So current plan is that some of us will be logged in using our hubs if we're doing it. So we have two options.
Yeah.
First is that we do virtual, and in person.
Yeah.
That's probably what we're going to do.
The virtual folks just hang out here.
Yes.
Right.
So the other one is that we try setting up some people to be online as well. And then we randomly do the breakout things and then we group one person online and the other person.
Right.
I've sort of done that when I was running RPG games, but it doesn't really work out well because the person online is more likely to be ignored by everyone else.
Yes, right. Okay. So I suddenly understand. And it may be that we'll have, so we'll have this be one group.
Yes.
Then we'll have possibly two other people step up with their Zooms. Or they don't even have to step up with Zoom. No,
Yeah.
you just break out in person. Right. Okay. Got it.
Yeah, I'm half tempted to say everyone count 1, 2, 3 and go 1s, 2s, and 3s.
Okay, but we don't have to restrict people if they don't want to.
Yeah, but the main thing is we want a good mix.
Right.
Do you though?
Just thinking though that if somebody does from the online wants to attend, then we would just have to log in with a separate Zoom in the group.
Yeah.
Right. Okay.
Yeah, I pulled out my Chromebook. It doesn't have the best connection, which is why I've been using it, but we could use that if we do need another computer on hand.
Right. Well, mine as well.
Yeah. Yeah, we should have like a good laptop somewhere, but I need to see if all that.
Somebody would have to volunteer. Okay. So decision time. Between the online folks and folks in the room, first of all, any other suggestions for achievable goal in a little hackathon mini activity?
I think that some folks are on the wrong Zoom room right
I'm
now.
chatting right now.
So Ryan's just letting them know to join this one.
Okay. Okay,
Like
great.
Natalie and others are on the wrong one.
I see.
So we might have a
So
problem.
we have that switch. I did.
Yep, I just let them know.
Okay, great. Thanks.
So 3 and Magdalene.
Yes.
Yeah, they're the ones.
Okay, so that other room was still open.
It was.
Okay.
Somebody chatted in there. Can you hear Lauren crunching?
Oh, I
They
see.
wanted to do that.
Oh,
You know what?
True story.
I didn't close for lunch. Okay.
Is there an ogre chewing rocks in the room?
okay.
Yeah, you'll be there.
Damien, I lost the last bit, what you said. Could you repeat or maybe type in the
Okay,
chat?
we were just waiting for just a sec because the old Zoom room was open.
Okay.
People were on it, and now we're having them come over to the right room. Tarini still is on the older connection, or
Okay.
is just signing up. So I'm just waiting for a sec.
Okay, okay.
Just. Oh, right. I keep on forgetting. It's this computer.
Are you trying to justify to me?
I'll just send a note.
I wasn't there.
Yes, you start seeing this. That's why that's so that's the PDF. What I want is the turtle. Just like a whole worksheet.
Okay.
So we can start. I sent this to you. Okay, so I just sent this to you. I sent this, what I found. And that's useful. That's a good start. I sent it to you. Thank you very much. I'm still digging through this. And I have my video on this. It's just right. All right, where were we? Trying to do something meaningful here. Process monitoring stuff, identify core food graph competency questions. I think we just. Yeah, I think so. I'm pretty comfortable with it. Because here's the, this is supposed to be very good, so. I think we're going to feel off in the groups or something.
Okay, so Trini isn't on yet. Sent an email off to her. But let's talk about the how to do this. So there is the competency questions group, which I think is a kind of a clear mandate. And I would suggest we start that group, and we start that in the technical thing is that people can converse onto one Zoom channel if they're all interested in that topic, and that's this Zoom. And nobody has to actually be up here, but if you were all interested, how does that work? To talk amongst yourselves within this Zoom group and screen share, then
So
this.
So what we would do is go over here, more breakout rooms,
Breakout room.
and then we can manually assign, let participants choose which
Okay.
room.
Okay, great.
So it depends how many topics we
I
want.
can handle with breakout rooms if you know, if you want us to pay some.
Yeah. Okay. Right. So let's talk about at least one room dedicated to the competency questions and breaking down those into the user groups who are interested in them. Then a next group could be around data harmonizer and how to digitize the recipe model basically into an app that can allow people to add recipes and manage them and the limitations. And all of that's geared to loading it up with the vocabulary. So the question is whether one would have a third breakout group or just a subsequent one to the competency questions, which is pushing the recipe model further in the way that Tarini was talking about, combing through those recipes. And
Yeah, I think those two could be related. Like the competency could maybe have some scope. I mean, it doesn't have a scope, and neither does the recipe model. But if you want to like achieve something, maybe putting them together would give us like a tangible output.
All right, let's do that. So far, I'm thinking 2 rooms. Keeps it simple, but we can go from there. Good? Okay, let's do it. So I'm creating 2 breakout rooms. Let participants choose room. Room 1, room 2. And room 1, I will call, rename, competency questions.
Competency, also the, maybe it's the same thing, but I think the question that came up, what is the minimum information to reproduce?
Right. And, there isn't much space, so competency questions plus min info. All right, and then 2 is going to be digitizing the category, the recipe model, and that includes variables. Just getting them into the form and kind of like editing tools we can have around that, what's needed. And we'll.
Could we communicate in some way between these 2 workshops, like through a spreadsheet or something? Like if the competency question reveals certain variables, you know, the variables that you come up with can also feed the competency.
Yes. Let me open up a Google Doc and I'll drop it onto drop it onto the discussion, the chat board. And it will be
saying, Damien, but are you saying that we can have two different documents that are online, can be reached by both groups, kind of like a chat?
Should I have two separate documents, one for each group?
Yeah.
Okay.
And then kind of then we can, each group can check both and then see
Right,
where
we'll
we're
have
good.
both open in the browser. We can
Yeah, kind of.
check them out. Okay, that sounds good. Right, so I will create two Google Docs, and they can have pictures in them and stuff, and each community will talk and edit each document.
That's one way, I don't know.
No, that makes total sense. So I'm going to go create those, and then I'll pop them into the message group. So before you jump off, I'll have two documents to load up.
He was maybe gonna try and share the docs before people.
Yeah, but there's also an option for us to broadcast specific messages to the groups, so we can do that. I'll be opening up the rooms for what's going on, and people can choose their assignment. Okay.
Pardon me, sorry.
Yes, I'm not sure how everyone in here wants to organize on who's interested in room 1 and who's interested in room 2. So I'm thinking that we could have room 1 be the front and room 2 be the back, or that makes most sense with how people are sitting if we don't want to move. Okay.
I'm also wondering how we can communicate.
We're setting up a Google Doc for everyone to collaborate together for the.
Right. I get that. I understand that. But since I was organizing this with Damien, like I'm happy to let somebody else, like, you know, keep because it'd be very hard for me to coordinate, like keep notes or even Oshashi, because when there's like an in-room conversation happening, then someone should take responsibility of tracking that's actually in the room.
Okay. Yes.
So, sorry, Tirini, what was the concern? I really did not get you. What is it?
It would be good for someone to take notes or to track the conversation that's happening. And I feel like it would be hard for me to coordinate it, being online.
Tirini, we have Handy currently volunteering to track for the in-person groups. So.
Okay, so and I guess if there's like questions about sort of the food, the recipe domain, then it gets directed to us. Or...
So Tirini, my understanding is that Damien will be helping in person in one of the other rooms, jumping in between, while you can remain as co-host and actually jump in and out for the different breakout rooms, depending if people have individual questions or just some moving back and forth.
So I think I understand what Tirini is just said, and I will be there with group 1. I think you are also joining the competency question, is it? And I will try to keep track of the conversations and the pointers that we share, and I'll try to update the Google Doc that Damien had shared. Is that all right, Tirini?
Yeah.
I mean, we can try our best. One of us, I mean, I'm just wondering, it's kind of hard sometimes when there's a conversation happening in person and you're online. Let's figure it out. See how it works.
Yeah. The only constraint, okay, I might not be able to survive the entire afternoon session. So yeah.
Okay, and I've just popped the two documents onto the chat. So I'm hoping they show up there.
It came to me, Mama.
Okay, they are there.
Yep.
So everybody can open those two on their computer. I see a number of you don't have computers, so you'll just have to show online. Maybe the best thing is to actually open these on this and sort of show them side by side. No, no, wait a minute. This one, we've got to figure out which computer is.
I'm setting up a second computer that I cannot get, so.
Okay.
Yeah, I'm just waiting for updates
Okay.
because we didn't do it this morning. So.
Okay. Now, in terms of cross chatter, like, we'll just turn the sound down in this one. Like,
I'm thinking we remove this from the sound system and then use individual devices to coordinate. Or
so leave this a little bit louder, you saying? Yeah.
thing is,
Hello. Okay, you can hear me online, Rhiannon? Okay, great. So we closed up our two respective breakout rooms, and I think it would be time then to report out a little bit on those. And what we could do then is tackle a little modeling problem that glaringly is still missing from Food On, and that I think both sides of the room could, both breakout groups could contribute to. So first, to explain and explore what we did over on the data harmonizer side. It was kind of an exploration of LinkML, this new specification for being a bit of a crossroads between application development and the pure ontology view on things. LinkML's, I'd say, a gentle move to enable application development using ontologies, but without getting caught up in the class hierarchy and logic and reasoning directly that you run into if you try to develop an application ontology directly in an OWL ontology, which I've tried in the past. So what we're doing is just going through some of those pick list menu items and seeing how from a resource like Food Network and the recipe categorization systems on their websites, that their menus are chock full of items that are actually semantically different, and that if you tried to put them into a single class in an OWL ontology, that simple, what looks like a hierarchic menu, that the reasoner would declare lots of errors. So how LinkML enables you to create enumerations of things that aren't necessarily directly connected to a reasoner, but how each selection on a menu item could be turned into, say, a filter on a knowledge graph to select, say, the recipes that you're interested in. Whether it was, in the example that was tossed around a little bit, was the Food Network quick and easy recipes, which are actually looking for quickness, so quick processing time, but quickness delivering the food, not just the fact that you only took 5 minutes to prep it, possibly, and then the easy part, the complexity of the recipe. So exploring how LinkML could make a couple of menu items out of that, or keep it in one menu item, and then shoving the functionality of such things in your specification off to other software to handle. And the fact that LinkML is being used on different projects, and that we'll try to apply it to food ontology, recipe modeling. But yeah, so that was where we ended up with, is looking at the meal type. Started that exercise of hunting down these terms online in OBO Foundry, and realizing OBO Foundry is a little late to the world of human behavior. In the life sciences, lots of organisms studied, but humans as a behavioral entity with desires and preferences, that language is still coming around. So meal type, we left it kind of looking at meal type and wanting more of a formal definition for what dessert means, what main course means, the dishes that are served out, and then the occurrence, I think they are these kinds of meal. So that could be a little exercise that we work on as a joint group, but first to ask if anybody wants to report out on the competency questions group.
Yeah,
I have to step out. Do you have?
I summarized the conclusions, and I think different people can elaborate on the points that they made. So we concluded on, basically, I think I summarized the conversation as what is in scope of a recipe model, because many questions come up when you're talking about recipes and ingredients, and what is not in scope. And as far as the easy concept, we decided that it was very, very subjective. And we cannot probably have an exhaustive list of what could be objective, but some of them would be, some terms would be the time taken, the number of steps, equipment requirement. The reason why this would not be objective, as you know, Rhiannon made a good point that what takes 5 minutes for someone could take 30 minutes for someone else. So that makes this like, these are good terms, objective terms to have, but it does not exhaustively then define easiness. The other thing was also about the quality or the property, because one, flavor is a big part of the outcome of a recipe, but also quality and property are very subjective. But we did think about what's an objective way to approach this. So again, what's in scope, what's not in scope. And the way we thought the most objective way would be to go from the ingredient to the molecule to the chemical. And we spoke about this, of course, you know, in context of potato. So you go from the potato to the molecule to the chemical property, and that's how you could have an objective property or a quality association. So we basically stopped there. So it seems like a very concise conclusion, but there's a really good discussion, you know, prior to that, and we could elaborate.
Okay. So stemming from that, did you kind of get a little bit more of a refinement on the categories that you're kicking about earlier on in that potato recipe mock-up?
Actually, we didn't even end up looking at that, but I think that yeah, I mean, from our conclusion here, I think it confirms that ingredient, you know, for sure belongs. Maybe there's like a concept of a main ingredient, because one could say, give me recipes with potato. So ingredient is of course important, since time, number of steps, and equipment is important. Also, you know, identifying the equipment is a term that belongs in the recipe model. So yeah, as far as recipe model goes, equipment, ingredient, main or secondary.
Okay. Any other comments from the floor about what's happened in each work group?
To summarize that we discussed, start from exactly trying to see what was in scope and what we could define, and from the term easy recipe, and the fact that we could not think of define easy without some objective thing, and that's where we reached the point that there are subjective thing and objective thing, and we should focus now on the objective one, because then otherwise, you know, easy could be easy to live, and then most difficult for somebody else, so very complicated to define easy. And we thought that maybe capturing these things, that is the ingredient, the device you need, the step, etc., will help us maybe in the later future, when we have a lot of data associated with this characteristic, this information, maybe we can come out with an easy recipe defined afterwards. But it's very easy for now. We decide not to go and define easy. We will certainly use the term easy to search, but not to ontologize them.
Okay. All right. So the picture I'm getting then, and this came up at IC Foods conference before, I remember in a workshop, the subjective versus objective categorization of food. And so the low-hanging fruit is the objective categorization, which is the chemical constituency. And then once you've got the terminology, language able to describe that, then you can turn over to these color or taste wheels or smell wheels, organoleptic wheels that each food industry, like the wine folks, have for human subjective description. And then you'll at least have the analytic versus the subjective to try to machine language correlate or something like that.
Yeah, so you know, like just staying very focused on the potato example, what this would mean there is there are two types of starch molecules, which is a predominant composition of potato. And one of them is amylopectin, which gives a waxy quality and or property, if the word quality just sounds too subjective. And then amylose gives a floury quality. Now, this is confirmed, this is like rooted in food science. And then those two, if you could assign like a physics property, would be viscosity. And then after that, you get to all of these other sensations like creaminess or rubberiness or whatever that have to do with certain range of values of viscosity. And when I say range, it's not that everyone agrees viscosity value 50 is, you know, creamy or something. It might differ, but you could go in these sort of steps. So at the most objective level, you would have the chemical, and then associated with the chemical is a property, which is now sort of kind of, it's become so standardized, it gets used in food science language, like it would be waxy and floury for potatoes. But even this language you find has an association to potato. You know, rice, you may not characterize, even though rice has similarly those starch constituents, you wouldn't use waxy and floury for rice. So already at the second level, you see it is objective, but it is in context of potato. And then you get to the physical measurement of viscosity, and then finally comes sensory. So it like increases like this. So we at least, I think, agreed that there is a certain broad, or there's an objective measurement, which is maybe a little bit broad, and then it starts becoming specific, which is context or instance dependent.
Okay. So I know Pato sort of stops at, say, increased viscosity and decreased viscosity, and therefore it would end up being a specific standardization project to try to measure viscosity and offer a gradation or scale to that. And we would be then turning to sort of analytic databases that have some ontology components in them, and maybe even instances of viscosity measurement of some kind, but you would have to know the analytic procedure to make any sense of that scale.
Exactly, like viscosity is often described as a resistance to force. So there would be a kind of analytical measurement, or at least like a physical definition, and that physical definition may be the instrument that gets used. There could be a number of instruments, but at least you have a physical definition.
Okay, I see, Matthew, you have your hand raised. Is that happening now?
I'm so loving this conversation. Wish I could have joined earlier. It's really fantastic. Yeah, around viscosity, there's lots of different forces at play. There's resistivity, there's adhesivity, and there's cohesivity, and they occur in different ways. And to Dorini's point, there's several.
You dropped out for a sec.
Pardon me?
We're not hearing your audio.
Oh, I can hear. Can you hear me, Damien?
I can hear you.
Still can't hear you, Matthew.
What? Really? Could you hear Rhiannon?
Yeah. Can you hear me? Damien,
I can hear her.
Yeah.
No, we can't hear you either. Oh, no. I didn't touch anything.
Well, I think Matthew was kind of giving more of more theory behind the concept of viscosity, but I don't think he disagrees that is, so he didn't have a point, I think, to make to the contrary. I think he was just elaborating more on why this is suitable.
Yeah, well, there's so many variables that when you get into the technical stuff. So
Yeah.
they're scoping degrees of all this, and so maybe I had always framed. Oh, you're back, Matthew?
Oh, you can hear me now.
Yes, now we can.
Okay. Yeah, no, I was just saying that that viscosity, to Dorini's point earlier, is a great exemplar of measuring food structure, and and it includes aspects of resistivity, but also cohesivity and adhesivity, and there are varieties, because sometimes we want to measure things like, for instance, if you were to bite into a gnocchi, right, which is made from potato, you wouldn't really be able to measure the viscosity of the piece of gnocchi, but you could measure the resistivity of it in the bite and the compressive force that's required to actually bite it. And then when you open your mouth, how much it sticks, the cohesivity to your teeth, right? So there are lots of these things that we can actually measure, and is pretty well documented in the food science literature. This is would be a great exercise for a literature mining exercise, to do natural language processing, concept extraction, things like this, to be able to build out that essentially the pedo ontology, if it were, or the food portion of, what is the phenotype of the food from a physical structural point of view.
Right,
So
so
I was, as she said, as Doreen said, I'm offering support for this. I'm not
right. No,
contradicting.
I'm realizing two things. One, whether pedo is interested in taking on scales or gradations beyond increased and decreased, and at the same time, so it may name levels of measure of, say, viscosity in one of those dimensions you mentioned, in maybe instances, but then we would have to back it up with the analytic methods. So what you're talking about, to me, calls for one example of creating a standard for a measurable, named measurable, around one of these material science specifics.
Yeah, I think that's what I was saying. I think viscosity is a great thing, because there's so much to it, and there are many different kinds of instruments that you can use to talk about it. And it's not just a increased or decreased. There are different kinds of viscosity. There are types of viscousness that the more you mix it, the thinner it gets, and there are types of viscousness that the more you mix it, the thicker it gets. It's called a shear thinning and shear thickening liquid. So what's in pedo now is not adequate from a food science and technology point of view. Not even from just it's incorrect just to say more or less viscous.
Yeah, I think also food science is it's not a linear science like that. So you can't say that viscosity just increases always like this or decreases. But I think one of the things that I could, refer to a simpler concept about temperature, for instance, like, 100 degrees, depending on what the material is, could sterilize or could pasteurize. So, like there you could use, you wouldn't say increasing in temperature, but maybe you would assign a value to a temperature and say this results in sterilization. So it may be that sort of idea, like a certain value of viscosity meaning something, and not just an increase or a decrease.
Yeah, I see use in both camps, and that's all about what our work on process by objective, where the objective has some thresholds versus absolute thresholds versus relative thresholds. So if I have chopping as a process, I can keep chopping, and the stuff will get smaller and smaller and smaller until it's mush. That's process without threshold objective. And yet Pato is still fine for describing without the absolute threshold. So now we have to explore this absolute threshold.
I like the concept of thresholds in physical structure, and we think about it a lot. Even if you think about the structure of a cake, and the structure of the air bubbles inside the cake and how it rises. If you think about a tortilla chip and measuring how crispy it is, well, you can actually measure that with the sound when the chip breaks. So there are a variety of ways that we could get some of these sensory metrics in as thresholds that I think would be quite valuable.
I touched on that a little bit earlier about when to notice when a liquid is boiling. It's not just by the temperature, but sound and so on. Right, well, food processing is game for all of that. Okay, what's the other thought to take away from that? So just in terms of Matthew, what we need then to demonstrate hard food science use of ontology beyond Pato in establishing a standard, or at least the ontology mirror of an existing standard, would be a nice tight example of one food industry piece of equipment that generates a standard measure of some kind. So maybe I can follow up with you after about that.
Yeah, I think
there's a little
viscosity
modeling exercise to show how it could be done.
So we've got a conceptual model around viscosity that I would be happy to share.
Okay.
That's got instrumentation.
So now that we're merged together, we could shift to just doing an exercise together, a workshop-y exercise. And the one that came up on our side of the fence was defining meal types and the dishes that are allowed to be served within them. And at the moment in Food On, it's a bit glaringly absent, a hierarchy of meal types, or at least a list of them. What we did was just sort of try to sidestep that challenge by talking about foods that belong to a meal type and just having a class of those kinds of foods. So breakfast food, dessert food, getting to name things that fit the category without really defining what the category is. So one exercise could be to work together a little bit with a diagram tool right online right now, which I could screen share and try to rig this up so that I can actually talk through the microphone here and we can talk through the problem. So I think I'll try that. I'm literally scooting this little pedestal out over without unplugging anything to my computer and sharing my screen. And then talking through this problem of meal course and meal. So what we discovered was that NCIT, a vocabulary that has been loaded into OBO Foundry, has dessert and dinner and breakfast. So I'll just take a little scoot over to show that. So if I go into OLS and look for breakfast, NCI thesaurus, the first meal of the day, usually in the morning, period. Supper, evening meal, usually the main meal of the day. And lunch, a midday meal, sometimes also called dinner. So I get it, you know, pretty simple. Let me copy these over. We'll challenge them and see if we can make some headway into defining meal and meal course. And are you all comfortable with this exercise? Food On kind of needs it, so I appreciate time on this.
I'm a little concerned about the level of subjectivity in this.
Well, yeah.
It's so culturally dependent.
Oh, I'm totally wanting these definitions to be challenged and cross-culturally validated, and maybe some of that we don't have people in the room to do, but
yeah, that's kind of my point, is that it's going to be pretty ethnocentric, whatever gets developed here. I mean, even something called tea, not tea the drink, tea the meal. you know, I don't think it exists in Ontology, but it's a meal, and it can mean different things. Is it high tea, or is it just you know, tea as in supper or dinner or lunch?
Okay. Well, that particular thing, I think we can weasel our way into the semantic question of by saying tea, high, noon, or tea, beverage.
But I guess my point is, I wonder whether this belongs in an ontology, or whether these terms belong into something more akin to a folksonomy that get mapped to something called, you know, first meal of the day or main meal of the day or something like that. That doesn't have the that doesn't take an opinion on whether it's called lunch or dinner or tea.
Right, so that raises synonymy. How can we define classes that are pretty clear in their meaning, and then deal with the language of synonymy as it shifts from culture to culture, English speaking community? So I like that idea, I like that approach. So maybe we can run with that a little bit. Oh, on my computer. No, not on mine, on this one. Oh, because it's not plugged in. Good, let's save the day. Let's plug this sucker in. It hasn't been in. Okay. Okay, good. Whew.
I wanted to maybe offer, the last question you had is how to address synonymy.
Yeah.
One way that we're addressing it in our work group with federal partners is local control vocabulary versus a canonical control vocabulary. And so that's how your canonical control vocabulary is like your set of universals that everything maps to. And until something, and then your local control vocabulary is anybody can call anything they want, but it'll have a universal first order logic description of what it is at a higher level universal set of classes. And at some point when the local control vocabulary has enough usage or whatever set of standards, like when things rate either usage, utility, endurance, and persistence in a larger community, when it meets some set of standards, then whoever governs the canonical control vocabulary board, it can be promoted up. So that's what we're working out right now across a bunch of federal partners. It's the very same issue because it's the same thing, whether it's food or, you know, missile defense, it's the same concepts. So that's how we're working through it, if that helps.
Gotcha. So that fits in with defining the class and axiomatizing it enough on its own terms that you don't have to know what its name is to make semantic sense of it.
Correct.
Can you tell us who's talking there?
We are we not muted? Are we muted or something? Did you hear us?
Oh,
No, I mean the other voice in the room besides Damien's that I don't recognize.
Oh, I see.
Ryan Rakucci, U.S. Border Patrol.
Oh, cool, thanks. So I guess I agree with you, Ryan. My suggestion is that the canonical terms do not use things like breakfast, lunch, and dinner because that represents cultural bias.
Yes.
That may not be used. And so calling things main meal of the day or first meal of the day or something like that would be more appropriate. And then let those other terms that are more culturally subjective map to those from the local vocabularies, as you call them, or the folksonomies.
That's right. That's something I've been arguing for, which would be a global canonical control vocabulary and not an American one, but that's a different argument.
Yeah, that's great. That's great.
Okay, so that argues for having I think we can still call it a meal of some kind, or what would we have as a most top level class for these meal events of the day?
Well, I mean, it's temporal element, right? That these are associated with either timing or time.
Yeah, I think you could classify them in different. You could classify them as first, second, third, fourth, fifth, maybe.
Sure.
And then you could also classify them as a main meal, you know, or you know, some sort of second class main meal or next main meal or something, and then some kind of, you know, sort of snack or something like that.
What if you skip your first 3 meals?
Yeah, then you have a main meal after that, right?
Right. What do we use for brunch?
It's a main meal on a Sunday. I'm just, as a for example.
This is Sunday, yeah. I don't know.
Now I'm starting to see why nobody tried.
Well, the answer is who cares? Annotate the meal, however, whatever is meaningful.
There is something about noon and morning and evening though. It's showing up. Okay, hands raised.
Yeah, so you mentioned earlier to use like the ancestry ontology
Yes.
object properties to actually indicate the origin of certain concepts. So say we were using more like hopefully.
Can you repeat the comment or move closer to the mic?
Link that to other countries.
Yeah, I definitely see being able to distinguish it, a sense of a term based on its cultural thing, which is sort of an exercise in stripping away all the names and just looking at the axioms of each term. But there is this challenge of how to get started with that. With terms like breakfast and lunch, lunch has tied into it in the middle of the day. So is there a universal we could ask for?
I actually think that application-wise, if we're thinking like not pure modeling, but application-oriented, I don't think there's anything wrong with using breakfast, brunch, lunch, dinner, snack, coffee, tea, all of it. And I don't see why we can't include all of it. And then because in all of the applications, when I search for Google, for example, I do this search often, like find me restaurants with good brunch. And it does bring up stuff that has good brunch. And I think there's a good and valid application to this ontology. And based on that, I think we should use the regular, currently American English cultural based, and then we can kind of evolve it into cultures as we go along. I don't think tying it to main or like first meal of the day, I don't think that's naturally, that's application oriented. That's good.
I think there could be.
Yeah, so compatible, exactly. Yeah.
I think there's utility in questioning from both perspectives, but I do believe in the power of ontologies to define within one group of terms which sense or variation that you're interested in, and then leave the inference to determine, say, whether that was the first meal or the second meal or so on. But I like what you're getting at, Matthew, with trying to strip away, basically the exercise to strip away a kind of meal into its axiom, minimal axiom. So what if I provisionally say there's to keep each community engaged meal by order in day, and then we'll have a second meal branch, which would be meal by roughly by time of day, in day, time in day. And then we could start to talk about, in this camp, meals before noon and meals at noon.
That would be assuming that everybody woke up at like 0600 hours and went to bed at 2000, right?
Well, this is what I'm testing out. Can noon, high rise, high sun, high noon.
Well, like for instance, I worked midnights for many years. I would get up at 7 p.m. That's when I would have breakfast.
Okay.
Meal one
Excellent.
would be at 1900.
Excellent.
And my noon, I'd be asleep.
Right.
So
I see.
if you labeled it as meal one, it would apply to me on any shift that I worked or any time period, as if that would be my first meal of the day.
Right.
Yeah, I agree.
Okay.
And I think that even having the
So from my point of view, the order they come in the day is fine. And I would say that the term breakfast or lunch or dinner, from the ontology perspective, I would see as being a role that you give to that specific meal that comes in the order. So anything that comes as a second meal of your day could be a lunch, as a raw lunch.
Subordinate to
for
the
you,
meal 1, 2, 3. Would be subordinate.
And is coming as the first in order, then you have roll breakfast.
All
So
right.
that you can, some cases, if you have as a roll, you can really attach in different places that you want to not stick to that definition of being exactly in only one place. It's something that depends on the context. Usually come in order, but
So here we need a term actually to talk about the human cycle, the human-centric view that you're talking about, not the natural-centric, but the work day.
Yeah, it would almost be like a 9 to 5 workday or a anomaly.
Yeah.
But breakfast isn't always the first meal. When my kids were small, they loved to have breakfast for dinner.
Yeah.
What does that mean?
Yeah,
But that would be the food rather than the event.
Right.
Yeah.
But we have to make that distinction.
Breakfast food. You would
Okay.
say, find me a restaurant that has breakfast food. And that everybody understands that will be pancakes, eggs, what have you, right? And then that's kind of,
I think even this is kind of suggesting something that may be not right. If I could eat a steak as a breakfast. So that's the point where I really think that you can give a role to the breakfast or lunch, and whatever you attach that to, whatever thing you think is for you, the breakfast or lunch, makes more sense, because there is not something that you clearly define as being breakfast. What is the breakfast? And we go on the definition we gave before, subjective and objective. Yeah. So you don't have a way to objectively define breakfast. Because it really depends, what are your habits, which are my habits.
So, breakfast food which in pre-industrialized civilizations that did not have light, electricity, or fire.
Well, can we also differentiate between?
No, this is all good. I love it.
Could we also differentiate between breakfast style meal
Oh yes,
versus
online.
breaking your
Right.
back?
Let's start with Rhiannon.
Okay.
Your microphone.
Can you hear me? Can you hear me, Damien?
We can't hear you, Rhiannon, yet.
Okay.
Sorry. Maybe we'll switch to Matthew and then see if that resolves. Okay, Matthew, can you try unmuting?
Matthew, you're muted.
Or actually ask to unmute. Yeah, right, ask to unmute. I'll try that. Or are we getting the same sound problem that we had before?
I think it's the same as before. Can you hear me yet?
We might be. Can't hear you, Rhiannon, or Matthew. Nothing I've changed.
Sent a chat.
Chat? Yeah, maybe do chat.
I did.
Contact here on the chat. Rhiannon,
She put it in the chat.
I'm seeing the chat now. I'm just not sharing it. So Rhiannon says, can't we differentiate between a breakfast style meal and breaking one's fast with breakfast? Both are still used colloquially in modern times. And so pointing out that breaking fast at any time of the day might be broken with a breakfasty style meal just to kick off regular eating again, right? So I think I totally get the point that there's this breakfast food and it's not necessarily served at breakfast. There are these 24-hour breakfast joints that pride themselves in serving you breakfast any time of day. So I like that distinction. But then breakfast food if we're stripping it from its historical roots, we can sort of offer a free text reference to history. But then how else would we describe breakfast food if it's not time of meal, and if it's not main meal versus secondary or third or tertiary meal of the day? Then is it just an arbitrary grouping of food styles?
Culturally and geographically dependent, I think that's the problem.
Right. Okay.
So I mean, maybe you got to put something in there that regionally, culturally dependent. Typically, it's the first meal of the day after waking up.
So I can see that in a free text definition, but I think we would have to quickly go into one thing in Food On we've introduced is a term called Western diet. So is it possible to generalize breakfast food as a Western diet breakfast
I
food?
agree that it changes from culture to culture, which I think is what you're getting at with the Western diet. Soup is a very common breakfast food in Turkey. Like I will have soup for breakfast.
What's that?
Soup. Again,
So
culturally.
there's a case where if new people, if people can come to the Food On curation team and say, my culture has this set of kinds of food for breakfast,
Right.
then we would try to satisfy that by manually linking this category to those food types. And then establish possibly in Ancestro a cultural link. Okay. So it might be very specific, like Korean breakfast food. We would have to skip pretty quickly from breakfast food straight to the diet and not think about the time of day question at all. Okay. Barry, how are we doing so far?
I'm assuming that you need some culture neutral starting point, and then you can make culture specific versions of that culture neutral starting point. And the only thing I can think of is time of day or order in there. I don't have a feel about time order versus time, but I suspect time order is probably going to be more resilient.
Moving from breakfast to lunch to dinner, regardless of which hour of the day for a person.
Yes, but then in some cultures you might commonly have more than three.
Mm-hmm.
And but there's no way of solving that problem by means of time rather than order. So.
Mm-hmm. Right. So one strategy there is to back off from the ordering.
Maybe you would do it the first, second, third, and then sometimes there would be a fourth and a fifth.
Mm-hmm.
And there would just be, for those cultures which have a fourth and a fifth, there would just be no mapping. But still, it would be an objective starting point.
And that's what Matthew Lang proposed as a starting point. 2.
Are there any cultures which have 5 meals regularly every day?
Yeah.
Namely?
I mean, even in the US, like if you are recommended from your dietitian, we small frequent meals, like I could recommend up to 6+ meals a day, which might look like a snack to somebody else, but that's.
But do they have a canonical term? Like when I do my meal prep, I eat my 6 meals a day, but they're not aligned to like anything except for time to eat number 3.
Or that should be considered a continuation of lunch, like first one, second one.
Yep. Whatever.
In my culture,
Okay.
there's like 2 times, and then, like after dinner, there's like coffee and
This is a dumb question. Why focus on the meal and not the food, and then just attribute what it relates to with what meal, what culture, and what time for what function? Because all those meals serve a function.
We were running into problems with that, like with cake. is to have cake for breakfast, but cake would generally fall into what we would eat for dessert or as a post to dinner or something like
Yeah,
that.
well, who cares? What problem are you trying to solve?
Are we?
What are you trying to reason about?
Yeah,
That's
what are our questions there? Are we really trying to be able to ask like, okay, I want to eat eggs, when can I eat eggs? And the answer is anytime we feel like cooking eggs, right? But it should show up for sure under breakfast, like.
I think we want to be able to answer the question by somebody as, you know, something to eat for breakfast. So we want to be able to say that without giving all these limitations. So my point before was going with the order in time, because we are having our first meal in any place. There would be a first meal, then there would be second and third, whatever they call it, still the first, the second, and third during the day, and then associate to that what I think, and now that is going to be the role that that meal played in that specific context. It could be the breakfast, the lunch, or whatever. But you still have an order or a second breakfast in the country that where they have the second breakfast or the second lunch. So you are not defining that independently from when you're eating, but you have the first, second, third, fourth meal, whatever, in order during the day.
Would that work for Turkey?
Fair.
Would it work for Turkey to have a second breakfast and a second lunch?
Well, I think breakfast, morning coffee, lunch.
And I would say that
Tea time,
that is,
dinner, and then maybe a.
so the coffees don't count.
Yeah. Well, how do you do it, you know? Morning coffee can turn into a meal. Yeah, it's a, yeah.
So in England, there is breakfast in non-polite company anyway, dinner, which is served at lunchtime, and then there's tea, which is a meal, and then there is supper, and sometimes there is also a late supper. But still, everyone would say there are only 3 meals in a day. Because tea isn't really a meal, even though you eat food.
Food defines a meal.
Bigger than tea.
Bigger than
Bigger than coffee.
Tea would be the standard.
Tea and coffee are what you focus on at tea time and coffee break, where food is what you focus on at breakfast, dinner, lunch, or supper.
When I think about tea or tea time, I think about biscuits. I think about cookies.
Yeah, but you call it tea, that's.
That's true. That's not. I think that's not the first thing that comes into my head. That's almost like tea is a given. Like what else is there?
Well, in Germany, you have to call it pudding. You do want to have cake time, as opposed to tea time. So the focus apparently is cake.
Sounds like some mapping's going on.
We're losing people.
Just notation, the blue lines mean ISA, and I don't have any other relationships on here, so.
Do you mean by order in waking day or in working day?
Yeah, I was trying to think.
Because I think the meals on Sunday, certainly in some cultures, can be a bit different.
Yeah. Forgotten your name.
Christmas Day.
So one of the things that I brought up was because I work midnights, I'm an anomaly, I work midnights. So generally I get up at say 7 p.m. I'll get up. Well, that would be my first meal of the day or my breakfast, where it would be dinner for somebody else with their third meal of the day. So depending on when you woke up during the day would then start your cycle of events for your first meal, second meal, third meal.
And do you have breakfast at 7 p.m.?
It really depends on what my wife made, because if she made me breakfast, I'm having breakfast. If she made dinner, I'm having that too on the here. So it really determines, she determines my fate.
You're really going to mess up the nutrition survey. So.
But yes, that would be, what I would consider my breakfast would be 7 o'clock. What I had for breakfast then would.
Yeah, and the name breakfast, so it's the first meal of the day, breakfast, caused by the night business, in most cases.
Right, and I would still call that breakfast when I get up.
And in Turkish, similarly, it's kahvaltı, which is before coffee, coffee, coffee. Before the morning coffee, that's what you do. And then you have morning coffee.
Can you hear me?
Well, that is,
Just a point, 3
Can,
yeah,
I'm
we
not
hear
sure
you.
if you can. Oh, great. Okay, great. So I disconnected and reconnected because I was having trouble. I was trying to talk earlier, and so I missed part of the conversation. And so just tell me if I'm repeating something that was said. But I think fundamental to this discussion is maybe first delineating what the difference is between a meal and a snack, and because sometimes midnight pasta is a meal, but what do you call that? And it's a meal that's often consumed after one's been out partying. So what is that? Or is that just a snack? Because typically we call those kinds of things a midnight snack. So what's the difference between a meal and a snack? And I think we have to do that before we start asking ourselves about the types of meals. We have to actually ask ourselves, what's the difference between a meal and some other form of eating and drinking event?
That's what I was trying to get at with the sustenance role, where
appetizers.
That's different kind of grouping, sorry.
No, go ahead. What?
What makes it a snack? Is it the caloric amount? Is it the nutrition difference? Like, why is that not a meal? I think that's a meal too. I agree. I think a snack is a type of meal.
Okay.
And it's so
Maybe
subjective of why.
So you're saying a snack is a small meal?
Yeah. And the small, depends on what you're snacking on. I mean, if you're having midnight pasta, that's not a small snack. That's a meal.
Yeah, and still in context of person too.
I guess it depends on how much pasta.
A meal for a kid is a,
Okay, that would still keep us kind of within 2 categories, and we wouldn't have to do 3 fuzzy boundaries, just 2 fuzzy boundaries. We just have 1 fuzzy boundary to deal with.
Are appetizers a meal? If you go for happy hour and get appetizers, is that a meal?
Yeah,
It's a meal.
I would call it one.
Yeah.
Vegan French fries are a meal.
Your meal, then yes, it's your meal. And it could be a first course of a meal for somebody if they choose to eat a second course, but if you've decided this is what you're eating for the meal.
Right, so there's a little bit of a distinction we were exploring was whether we could talk about meal course being like a single dish versus a meal being a composition of dishes. I have been associating this whole meal hierarchy here, allowing several dishes to be served up during the experience. And even here, actually, this snack starts to get down to 1 dish, maybe, whereas a main meal could have several dishes served. Does that ring true?
I don't think that's necessarily the case. If I'm eating through my fridge and I see a little bit of salad and a little bit of mashed potatoes, I could eat those together and help with a snack. It'd be gross, but I could do it.
I see. Could we say if you kept the 2 things in separate plates that we could call those 2 dishes, but if you put them into 1, then we call it 1 dish?
Intent of what it is. So the intent of a meal is to fill your belly, right? I'm eating lunch so that I'm not hungry, where the intent of my snack is to carry me over until the next event. Would that differentiate it at all?
There's all sorts of motivations for a snack. They may not be about hunger, it might be other things. So
So I will tell you this, I think a way to go about defining what a meal is, to go about it by looking at how different agencies look at it for defining things. For example, for USDA, a meal needs to have different types of nutritional components because they do meals for school, right? They do kids meals. But in those kids meals, they want to make sure that they have dairy and then
a certain amount of vegetables and fruits, and then a certain amount of carbohydrates and all of that. So that's
yeah.
what they call a meal.
And this is one of the reasons that in the 1980s, President Reagan classified ketchup as a vegetable so that school meals could be cheaper, and we could count that as one of the 4 food groups at the time. And so basically what I'm hearing is there's not any deal between snack and a meal. Potato chips and beer constitute at happy hour constitute a meal, or not. I tend to think that's not really a meal.
So let's distinguish between the event in which something happens and what is being consumed. So a particular dish is consumed, but is it part of an event? Which are we calling a meal an event here, or are we calling it a reference to food consumed? If the meal is an event, then various bits of food can be consumed during it. The meal is just a reference to one dish. I wasn't thinking of it as that. I was thinking of it as a little period of time in which you're consuming various things, which may be on one plate or not.
Are there not meal events?
Oh, you just dropped out now.
And darn it.
Can't hear
Can you
you.
hear me now?
Yeah, we can hear you.
So a meal is a process in Overton. And what we're describing now is the way in which an average day is divided into two distinct kinds of processes, eating processes and everything else. And some of those eating processes are special, they're called meals. And the number of meals on any given day is about 3. Some of them are also special, they're called snacks, or coffee breaks, or tea breaks. And again, on any given day, there are 3 or 4 of those, or less. Some people don't do snacks. But I think one thing that so that division between eating processes and the rest structures everybody's day. It structures the school day, it structures the factory day, it structures family day. So that structuring is what we're trying to get at by means of meals. And the meals have therefore a certain kind of ritual quality, at least in many cultures, because this structuring wants to be maintained from one generation to the next. So you teach your children to eat a proper dinner, not to waste their energies in snacking all the time.
I would.
Well, you were not properly brought up.
Obviously.
Okay, we heard you for a moment, Matthew, but
I'm just wondering whether we need a meal process, and a meal event, which might be different from each other, as well as some other sort of way to describe meal that includes, 1 or more dishes, kind of thing, and a definition about what that is. But I think that would be distinct from both meal process and meal event.
I agree with that.
Do you have a definition of event, Matthew?
No, that's your world, Barry. I'm going to leave that to you.
Well, I would just say one more thing, that the view I just presented in terms of regular meals, which have a certain ritual aspect, applies also in zoos. So animals in zoos are fed at specific meal time, and I think that might be significant.
Yeah, we also have other things like holiday meals, right? Feasts, these things that that are significantly different than what we're talking about here.
You dropped off, Matthew, if you were continuing there.
Oh, nope, just special occasion meals, which I think are a different sort of way to classify meals, and certain types of gatherings, like a feast is different. A feast is where, you know, you're inviting lots of people, but it's a special kind of meal, not necessarily around a special occasion. But anyway, it's just distinguishing that is
right.
Not simple.
So I guess I started out this conversation thinking there was a division between meal eating processes happening during the day for any particular individual, and then all these cultural events that have particular kinds of meals associated with them. But really, we should be able to come up with definitions that don't sound strange in each other's company around cultural ones, such as meals for Easter happening on a particular day, but that would be layered on top of, or those would be the exceptions to these daily eating processes. So
I need to leave in a minute, unfortunately, but I would just mention one more element which I think is important for distinguishing meals from snacks. So meals have a certain starting point and a certain ending, in many cultures anyway, also a certain ending point. So if you start eating before the meal has been started, presumably typically by the father, then you're doing something wrong. Where snacking can happen. And the supper is a special case.
To the process, and others have a religious, you know, moment at the beginning of it all.
Yeah, that's actually quite important.
Okay, thank
and
you.
You never do that with coffee.
Right. All right. Thanks, guys, for that input. And yeah.
Suggest like order the meal. I don't know if this could be one where it's like there's a person. I don't know what the OBO equivalent for DIX would be. That there's like multiple meals.
There's ability to say some process proceeds or succeeds another process, right? But they don't necessarily have loops involved in them, like a Petri net diagram or call it a finite state machine.
Right.
The only states of things are the qualities of material entities. But
yeah, because because we technically like go well up to like 7 for the
yeah, the fourth meal might really be the second meal. And which one's the biggest one? So I can see some research questions needing those terms to having to map them onto what kind of data. That doesn't invalidate having those terms for as global accessible terms for people to reference in food service.
just a thought.
Yeah. Okay, so we are informally closing up, folks, online. One big group had to leave before 5. It's 4:44 right now. So we will kind of fold this session, and I'll take these diagrams away and create a post-hackathon report out on where we finished here.
Good to see you, Rihanna. Did we lose Matthew again?
Yeah. Where's everybody? I guess you'd like to see a picture of us waving goodbye to you, faithful hackathoners. so yeah, some group of folks just left, therefore we'll need to close this down. Okay. So thanks, Rhiannon, and thank you, Matthew, and others for chiming in. Pardon me? Yeah, we managed to see some good stuff together. All right, I'll close it up now, folks. and stop the recording.
I just don't wanna. Go ahead and do that, yeah.